మాట్లాడండి.
ఓకే.
Hello, sir. Is it audible, sir?
Okay. My voice. Okay. Ravi is clear.
Yes.
It's audible, right?
It is audible, sir. Okay, sir. Okay.
Okay. Yeah. Thank you. Ravi, is it audible? Dr. Ravi? Dr. Ravi? Dr. Ravi Kumar? Okay. Very good afternoon, everyone. Welcome to ninth day of our ATAL sponsored faculty development program on innovative green energy generation and storage technologies. I hope you found yesterday's sessions interesting and are ready for today's exciting topics. Yesterday, Dr. Ban Prakash emphasized the importance of various next generation smart grid technologies. In the second session, Professor E. Anil Kumar, IIT Tirupati, discussed about the hydrogen storage technologies. So today's program include three technical sessions, and one session is for online test as well as feedback, and the last session is the valedictory session. The first session will focus on 3D printing in sustainable energy technologies. The speaker for this session is Dr. Murli Mohan, Research Manager, Next Tech Corporation Limited, South Korea. He will share valuable insights into the 3D printing in sustainable energy technologies. In the second session, Dr. Babu Rao, Senior Lecturer, University of Technology and Applied Science, Muscat, Oman, will talk about role of artificial intelligence and machine learning in green energy technologies. And in the final session, Dr. Vasu Kollangi, Deputy General Manager, BHL Corporate, Hyderabad, will give some insights on fuel cell technologies for stationary and mobility applications. I encourage everyone to participate actively, interact with the experts, and share your thoughts during the sessions. We are delighted to welcome Dr. Murli Mohan, who will be sharing his valuable expertise and perspectives on 3D printing in sustainable energy technologies. It is a privilege to have such a renowned expert with us to deepen our knowledge in this vital area. Before we begin, I invite our session coordinator, Dr. K. Ravikumar, to introduce today's speaker. Over to you, Dr. K. Ravikumar. Please share more about distinguished speaker of this session. Thank you once again.
Thank you, sir. Good afternoon, everyone. It is a privilege and an honor to introduce an extraordinary researcher and innovator in the field of advanced manufacturing and energy technology, Dr. Murli Mohan Chipu, sir. So, Dr. Murli, sir, currently serves as a research professor at Kukyong National University, South Korea, and plays a vital role as a senior research manager for Ambius Artificial Sun Future Energy Fusion and Plasma Project. He also contributes a fabrication engineer for Korean aerospace component, showcasing his expertise in both energy and aerospace sectors. Dr. Murli, sir, research expertise spans a diverse range of cutting-edge topics, including welding and joining technologies, wire additive manufacturing, process design and welding process digitalization, automation and manufacturing. His impressive contribution includes leading numerous industry projects focused on process development for flying cars, gas turbine blades, and Korean K2 tanks for defense applications. Has demonstrated remarkable innovation through his authorship of 6 patents, 60 essay index research papers, and 80 conference papers, further solidifying his reputation as a global thought leader. Dr. Murali sir actively involved in shaping the future of manufacturing through his service on the editorial board of esteemed journals, where he helps advance knowledge in his field. His exceptional work has been earned him several prestigious awards, including the Outstanding Welding Research Award from the American Welding Society, Florida, USA at 2024, the Outstanding Young Manufacturing Engineer Award from SME, Los Angeles, USA, the Young Scientist Award from Korean Welding and Joining Society, Seoul, Korea, the Outstanding Contribution Award from Korean Society for Precision Engineering, the Best Researcher Award from Korean Welding and Joining Society in 2016. Dr. Murali sir, groundbreaking work in welding, process automation, and fusion energy is not only advancing technological innovation but also contribution to the global pursuit of sustainable energy solutions. His dedication and expertise making invaluable resource and true inspiration to researchers and engineers worldwide. So I request, please join me in extending a warm welcome to Dr. Murli Mohan Chiku sir, whose insights and expertise will be enrich today's discussion. Thank you so much, sir. Dr. Murli sir, you please continue your session, sir.
Yes, sir. Yeah. First of all, I would like to thank Professor Shiv Subramanian sir inviting me for this session, and I would like to thank Dr. Ravi Kumar and head of the department and other committee members. So I would like to start my session, and good afternoon to everyone. My name is Murli Mohan, and Dr. Ravi has given some brief introduction. Thank you, Dr. Ravi. And so, is my screen is visible, right?
Yes, sir. Yes, sir.
Yes. Okay. Yeah, I would like to talk about 3D printing and sustainable energy technologies. Since this workshop is about innovative green energy generations and storage technologies. So I will try to cover the topics related to our main concept and including 3D printing technologies and their importance for these energy sectors. So during this presentation, I would like to cover the major topics about the overview of some sustainable technologies and the importance of 3D printing and the involvement of 3D printing in some of the major sustainable energy technologies like solar, wind energy, and the fusion energies, and some of the future scope about this 3D printing technology. So I think from last few days, you might have heard about from eminent lectures from various professors about sustainable energy technologies. So I'm not going deep into this introduction. So, um, so I will just want to give you the briefly so that we have a couple of energy sectors related to these sustainable energies like solar, wind, some hydro energies, geothermal, biomass, and also I would like to add fusion energies, which is not related to nuclear because it is something different from the nuclear energy. Here is called as a artificial sun. So we will see deeply what it is and how it is useful for future energies. So by using the use of these sustainable energies, mainly like they can minimize the impact of env environmental effects, and they can reduce the greenhouse emissions, and also they can compatible with the climate change, and they won't make any detrimental effect to the environment. And also, on the major thing is that we don't need to worry about the consuming the fossil fuels, the energies. So there is a known shortage of these energies, so that we can rely on these energies long term until we protect our environment. So there are so many research experts are working on this kind of sustainable energies, and there are many materials are inventing to increase the efficiency of these technologies. But the main point is that the transforming these ideas or these materials into the main product and get the output utilized into the practically. So the main key factor is the manufacturing methods from this research and the materials into the manufacturing and making into the process and generating energy. So even though we have very good ideas, but the manufacturing cost makes to some complex decisions to proceed with the final, to set up the process or not. So there are some innovative manufacturing methods which are favorable for sustainable energy sectors, that are like additive manufacturing and some advanced composite fabrications. So this method can be useful for like printing and manufacturing the wind turbine blades, and also for the electric vehicles. And if you go deep into the, you can see for drones and flying cars, and also for, and the next one is thin film deposition techniques. These are very useful for the solar energy technologies, and using the PVD and CVD techniques, and some of the high precision machining, and where the wind turbine gearboxes and nuclear power plants and the fusion reactors need some precision equipments, and the green manufacturing practices, and some of the automation and smart manufacturing uh, using robotics and IoT and some AI-based processes, and also powder metallurgy and some other like chemical processing and biomanufacturing techniques. So based on the applications and materials, there are several manufacturing methods are advancing nowadays. So among them, uh, additive manufacturing is growing much faster in the manufacturing sector, and many industries are very interested to adopt this technology. But I really thank our conventional manufacturing methods, which are sacrificed a lot for these many years to develop the extraordinary manufacturing parts and some of the products. But nowadays we are, like since the technology is growing, we have to change our manufacturing processes. So that's the reason we are running behind the new innovative methods. So let's talk about additive manufacturing in this session, and how these are useful for the this newly sustainable technologies, and how they can improve the efficiency of these energy sectors. So many of you are aware of 3D printing. It's not new, but I just want to give you some brief introduction. So unlike in conventional manufacturing, here we no need of any uh, use raw material blocks to manufacture the components. So if you want to make a ball using conventional techniques, we have to uh, buy the raw material block bigger than the component, and then we have to use any machining technique like lathe or milling or something like drilling or any techniques, and then we have to remove the material and we will make it. But in case of 3D printing, we have to have prior knowledge on your component, what you want to uh, make and what kind of features and geometry you want. If you don't know exactly, there is also recently some 3D scanners. The 3D scanners can scan your existing component and they can make the design. Otherwise, if there is a new component you want to build, you must have to have the design about those drawings. And using the design software, we can build the design and we can save those design into the .stl file. It's a stereolithography. It's a kind of format saving the drawings. So most of our uh, 3D printing machineries are readable only this file. So they can read the digital drawings into the processing movements. They can move the 3D printers and they can print the material according to the geometry. So as we see this cycle, we can create the model and this model convert it into the slicing, and then the 3D printer then use the softwares and it can make to print the materials. So based on the our input parameters, like how much width and how much thickness you want for one layer, so the 3D printing equipment can decide to print according to the input settings, and they print one layer by layer. They finish first one layer and then they start from that point, and again they will continue the cycle until it can finish up the final component. So after finishing the complete process, if it is necessary, we can go for the post-processing technique. But nowadays, most of the 3D printers are very advanced and efficient machineries. There no need of any post-processing techniques, especially the surface finishing and other things. So after completion, we can check our dimensions according to the drawing or not, and then we can release the product and we can utilize it. So that is some of the brief introduction of the 3D printing. So using this technique, we can use the plastics, the metals and ceramics, composites and biomaterials. We can print. Almost it can cover almost all materials, but still some of the materials are unable to print using 3D printers. There are various types of 3D printing processes. So those are designed and developed based on the material types and also the applications. So if you see the like wet photopolymerization, material jetting, and material extrusion, and binder jetting. So some of the processes can be hybrid, can be used metals and non-metals, but coming to the high directed energy deposition, there we can use only the metals, and those are very uh, large size components manufacturing techniques. So many of my friends are non-manufacturing engineers, non-engineers are always questioning when they hear about 3D printing. So everyone is asking what is 3D printing, why it is important. And so wherever they go, they are hearing, irrespective of the industry, okay, irrespective of the work culture, the 3D printing word is coming everywhere, is IT, non-IT, and everywhere. So many of my friends are asking me, how can we judge and what is the efficiency and how it is useful 3D printing process compared to the existing conventional techniques. So there's some best example. Since nowadays aerospace industry is growing much faster and everyone is adapted to use the transport by aerospace. So this industry using the titanium material hugely compared to other sectors. So in order to manufacture the components for aerospace engine and other parts, we are we are using conventional manufacturing techniques. So more than 80% of uh, the raw material is going to be waste to produce one part. No, so about 65,000 tons of titanium is going to be wasted only in the aerospace industry. It costs about $8 billion per 1 year, and out of it, 6.5 billion is the material value cost, and 1.5 is the machining cost. And material wasting is another cost, and also the machining. The material titanium machining is not so easy; it's very hard. So not all machining companies accept the machining of this titanium. So that's why, in order to prevent this kind of wastage and cost, the 3D printing technologies are really helpful. Like they're saving the material cost and also the. So how this 3D printing technology is growing all over the world, and what are the major major 3D printing techniques are leading this technology. If you see from last 1 year, uh, it's about 21 22 billion dollars marketing size in 2024, and it is expected to be increased until 110 billion dollars in the next 10 years. So the mainly the DED and SLM and EVM and powder base and the sheet lamination techniques. So all these are like supportive to the aerospace, healthcare, and some dental and automotive sectors. So if you consider all the sectors, it will be more than the what the survey has been conducted. So what are the main key takeaways in the world? So the United States itself, the market is uh, huge, and it is contributed more than 36% only in the 2023. And also the Asia and the specific region countries, their annual growth rate is about more than the US altogether. If you see the component wise, the hardware technology for the 3D printing is about 61%, but the software technology like design and some of the softwares which can be adaptable to the design software to robots and robot to the 3D printers. There are so many challenges. It's not easy task to adopt this 3D printing technology according to their component design. So everything is leading by the robots and the softwares and the coding and everything. So depending on this 3D printing technology, many other sectors also have a lot of scope, and altogether the market size is growing very drastically. So it is the graph showing like the only United States additive manufacturing market size. It's expecting to be grow very drastically in the next 10 years with the consideration of the demand of this additive manufacturing technology. So if you see the all over the world, how this marketing is captured by 3D printing technology. So the majority is United States, and secondly Europe, and then Asian regions. And there are some major companies who are, dominating these technologies like GE and Trump and 3D systems. Most of them are from United States and European countries, very few from Asian countries. And if we divide this additive manufacturing technology, there are two types: desktop 3D printer and industrial 3D printer. Desktop 3D printers means small size 3D printers. Mostly we can use it for training purpose and educational institutes and for the research purpose. Industrial 3D printers is for the actual manufacturing production. You know. So this is the manufacturing revolution, industrial revolution, where the conventional manufacturing process are changing to the 3D printing. So this is a small survey I conducted for the research. So, and this is another interesting thing, like some of the sustainable materials for 3D printing. So use it in the mass. So in the last 10 years, there's some research is conducting the NASA. They have a lot of challenges 3D printing in the mass. So they have technologies, but the major problem is the layer to layer, the bonding. So due to the gravitational issues, they are unable to make the quality 3D printing houses. So many are breaking, and due to the harsh weathers in the Mars, they are very collapsing. So they have NASA has been released some challenges who can solve these kind of problems. And one of the Korean professor, he the you know he conducted some research and he found some kind of binders to mix these binders in the material, whatever the material is available on the Mars, so that these binders can attach the one layer to another layer strongly, and they cannot break anymore with it at any cost of severe harsh weathers. And so yeah, his name is Thai Sikli. He's from Hanyang University. So he's uh, he's the one who conducted research with along with NASA. So I would like to summarize the 3D printing and what and their sustainable benefits for 3D printing is the material efficiency, and it can save the energy, and it can reduce the carbon footprints, and it can able to design lightweight materials, and also the recycling is very efficient compared to other manufacturing techniques, and it can reduce the resources using for the manufacturing. And also using this technology, we can advance our research and other innovation techniques. So I would like to give some ideas how this 3D printing is using for the solar sectors. So solar energy also trying to use this 3D printing technology to improve the efficiency of the solar panels and also reduce the manufacturing cost and some other benefits. Like till now, the solar panels are manufacturing using conventional techniques where the crystalline silicon, using for the immensely efficient photovoltaic material. And this material, using the conventional techniques, there's a lot of lengthy process, and we need a lot of labor and manpower, and it changes the costs a lot. And also there are some quality issues and the performance of the solar panels based on the manufacturing efficiency. So in order to deal all these challenges, this 3D printing technology, the still it is under research. It's not yet efficient, but so far some of the institutes and some companies together did some research, and they tried to do some 3D printed solar panels. So in this case, this is just the conventional technique, how currently we are using this solar panels. Initially, we will take some silicon ingot and we slice into the wafers and we produce the cells, and finally we assemble. But in case of 3D printing, the role of 3D printing to produce the solar panels, we just need the design flexibility. So not like conventional technique, there we have almost very restricted design, either flat or little bit in intricate shapes. But in case of 3D printing, we have more flexibility to choose the designs, what are based on the where we use these solar panels, and also the efficiency of the materials. So as I mentioned before, here we no need to waste the material, and also there is no need of much safety concerns where they can crack and lose their efficiency during the process. But this process is very stable, and it can improve the efficiency. And also the materials will not experience to any high thermal or other side effects to lose their conductivity and other things. And using this technique, we can increase the 3D efficiency of like using the optimal light absorption and also energy conversion within the solar cells. And using this 3D printing, we can also improve the production. We can improve the rapid prototyping, and also we can meet the demand. So nowadays, many industries and even the public want to adopt this solar energies, so that like the demand is increases, so that it is expecting to have 3D printing technology can meet their demands. So this just-in-time manufacturing approach and streamlines where the supply chain and mitigates the overproduction and overusing the cost efficiencies, and it can meet the response of the market dynamics. So these are the some current applications and innovations in 3D printed solar panels. So our research institutes, like they're claiming that using this 3D printing technology for solar energies, like there are some flexible solar panels. It is already confirmed. There are no much challenges no more. So we can use some diverse surfaces from using the solar panels, and also we can um, customize the solar panels according to the client's recommendations, and also the solar power 3D printers. And we they're not only manufacturing the solar cells, then again they're using the energy from the printed solar cells for the 3D printers. And also they're researching on the some advanced materials than the existing materials to improve the efficiency. And also there are the solar concentrators. So the versatility, and they pave the way for creation of solar concentrators. And they also claiming that there are some more challenges using 3D printing technology for solar panels. So the material selection. So the material compatibility for 3D printing and conductive to enduring outdoor exposure stands as a pivotal challenge. So as I mentioned before, even though we have several 3D printing technologies, but it is quite challenging to make them as a raw material flow to print into the flexible shapes. Still they're in researching stage to improve the material selection. And also there are some problems with the scale up challenges and the regulatory approval. So 3D printing technology is growing, but still we are lacking with the standards and also the approval. So due to the safety concerns, like still they're afraid to utilize this technology massively um, for utilizing in the large capacity, and also cost efficiency and the long-term durability. So these are not yet has been proved that they can give their durability is long term or short term. Still, it is in the developing stage. So any companies cannot guarantee any component right away. So these are the 3D printed solar panels. So this is one company is released these panels and they already started the production. So their point of view is that by printing solar panels by 3D printing can significantly boost the efficiency, and also it can the large surface area of the semiconductor ink, it can enhances the energy conversion, and they're claiming that 20% of the improvement in efficiency, and also it reducing in the cost, and also their manufacturing speed is much higher than the conventional one. So this is the process flow of solar cells using 3D printing. So in this process flow, we have to follow these techniques like front and rear passivated solar cells. And we use the aerosol seed layer print. If you see this yellow color rectangular box, so initially we have to make the seed layer, and above it, we have to make the second seed layer. One, due to the length and complexity of the turbine blades, in one set, is the printers are unable to print in the single component. So still we need some mechanical assemblies or some other joining techniques to join the parts. So still it is in developing stage, and it's not in the production stage. So still it needs to be advanced the technology. And 3D printing for the nuclear and other energy sectors. So nowadays, like due to the scarcity of energy, we also searching for the some other most efficient, generation power generations. Out of it, SMR is the small modular reactor. It can be most efficient and most safety plants we can use. There's also adopting this 3D printing technology due to the complexity of the design and the material safety. And this is the turbine blades, and also the turbine blades manufacturing by conventional techniques is a very lengthy process. They has to follow extrusion and forging, and also the heat treatment and the machining. And also there are some to improve the efficiency of this KF-21 fighter jet, the engine modifications, uh, also adopting this 3D printing technology. And currently, we also working on the aerospace technologies. This is the rocket engine thrust chamber. If you see the purpose of this thrust chamber in the rocket, where the energy is releasing and helping to move forward this rocket. So we are working on it to improve this efficiency for Korean aerospace. So we also trying to change this conventional technique into the 3D printing, because if you see this image, this rocket nozzle have so many welding joints. So we are not really happy with these welded joints, because even though we are taking care during welding, but some of the welding defects are uncontrollable. And if any defect is remain in this component, it costs a lot. We can't repair. So we have to just use it as a trash, this entire component. So in order to reduce the cost and improve the efficiency of the manufacturing, we are adopting 3D printing technology, but it is not so easy. It's too much complex design. So still we are trying to achieve it. So altogether, we have to use directed energy deposition techniques in the 3D printing. So there are powder bed vision and the DED and other many processes are there. But this wire-based art additive manufacturing is quite advancing than all these things. So it can improve the printing efficiency and in the production time, and also quality is also good using this wire art additive manufacturing. To the fusion energy. So this is the future energy which can, dominate existing energy sources and most efficient one, and we call it as calling as the artificial sun. So the energy releasing phenomena is almost like the same is like sun. Okay, so we have a deuterium and a tritium. In simply, if is I can say that like we will take these hydrogen helium elements and we pressurize them. We pressurize with a very high pressure and at the high heat. So at this stage, this nucleus can release enormous energy and the nucleus as like a ion gas. So this ion gas acts as a plasma, and there we use the this kind of conductors. These conductors around the plasma can observe, and due to the electromagnetic force, they will convert this plasma energy into the electrical energy, and it can generate a lot of energy and power. So there are ITER. So ITER, we call it as the International um, Organization. So India also one of the country is participating in this ITER group. So all together doing research to develop this mega plant. It's about 500 megawatts using this one. So this is started in 2007, but still we are in the developing stage. So this is the plant undergoing. So we already made some experiments, but within 10 seconds, the surrounding wall structures all are melt down. So the existing materials not able to withstand this high heat. So 10,000 degrees Celsius heat can be produced in. So that's the reason still we are unable to start the production. So the major point is like these are the inside wall where the new wall structure is directly contacted with the plasma energy. So the plasma energy have very high temperatures. So the existing materials are unable to withstand, but we are using some kind of composites and ceramics, and additionally we are also using some cooling channels. But still, there are some challenging issues. So we are trying to replace these structures using the 3D printing. So these 3D printings can able to mix the hybrid materials and can make new composite materials can build. So we are expecting to be have good material properties than the existing materials and can withstand such a high temperatures. So this is the plasma, and the blue one is the first wall. After that, there is a blanket, and then after that, vacuum vessel and magnets. There are so many layers to protect this plasma and escaping from the inner channels. So if we once we fail it, there's a use loss. So that's why the safety concerns are very high for this fusion energy reactor. So, yep. Uh, so currently we are working for this project, and we are developing the 3D printing technologies and to replace the welding and brazing joints, because the welding and brazing joints at any time can be melt down and can make some kind of defects. So that's the reason we want to have single component which cannot be manufactured by machining, but possibly can made by 3D printing. So one of the Italian company is proposed, there is a VS coils. These coils are tightly fixed by some brackets. So these brackets we need about 7,000 brackets in one circle. So each bracket three times need to be welded. So during welding, this welding heat cannot affect the coil, which can create the magnetic field. So somehow I found some techniques to avoid the welding effect to the coils, but still still we have a doubt that at any time, at any bracket can affect, we have to eliminate that entire coil from the assembly. So in order to reduce these risk factors, we are trying to have this 3D printing technology to replace these welding joints. So it's quite difficult to understand by explanation. So this is more than 20 years project. Anyway, so I would like to share some of the future scope. Yeah, there are so many startup, you know, ideas and startup possibilities in this area. So if anyone interested, it's a better chance to initiate the research. And we have if you see here, as I said, within 10 seconds, our entire the reactor has been melted down and broken down. So in order to sustain these high temperatures, we are still looking for the challenging potential materials. So we giving lot of projects to many institutes to research this kind of advancing materials. And also there is another idea. Instead of this fusion energy, there is a NIF, fusion target, and there will be a target. In the target, we concentrated laser energy. We will focus on the target, and the target nuclei can heat up by laser energy and can blast and can release the energy. The similar concept like fusion energy, but uh, by supplying that much laser to melt down this target is still is not available in the world, that much of laser energy. And this is the our donut shape of final fusion energies reactor has been melted down. So revolutioning reality, why 3D printing is the key to unlocking a limitless future. So as we know that the StarX, the Elon Musk is planning to mobilize the future into the Mars and other planets. So they already started some of the works, and see since the assembling of this is very difficult, so 3D printing is one of the technologies can be possible to overcome this kind of challenges. And this is about the employment growing by this 3D printing technology. So if you see from in the last few years, And in United States, the employment is very high for this additive manufacturing based, and likewise in other countries. Yeah. Okay. Thank you.
Hello.
Hello.
Ah,
Uh,
yeah.
yes, sir. Uh, so
Are you
yeah.
sharing it?
Yes, I can hear you.
Just one minute.
Hello.
Hello.
Is it audible, Dr. Murli?
Yes, sir. It's audible.
Ah, okay. Shall I? No.
Yeah. I'm done with my presentation.
Okay. I'll ask.
I would like to hear any participants have some
Okay.
comments.
Dear participants, do you have any queries regarding this topic? Kindly contact to Murali Mohan Chiku sir. He is interacting with you right now. You can ask any questions. Or else you can text a message in the chat box also. Any questions from audience side? Sir, I have a query, sir.
Yes. Yes, Dr.
So
Ravi.
actually, so this 3D printing, it is evolving in every area. So that is it possible to print the storage kind of materials? Is it, or else like electrical storage materials, or else thermal energy storage materials like batteries, or else some other basic metals? Is it possible to printable?
Yes, the storage batteries and like the phase change materials, they already started, but like still, the those are not up to the production stage. Uh, but there are some printing technologies are available to print these materials. There are on yeah.
Okay. So like polymers, how we are going to print that material? Likewise, here also we can able to print, right?
Yes, right.
Okay. So there is a query, sir, from audience side.
Okay.
Dr. Badri Srinivas garu. How about the use of 3D printing technology usage in welding? How can we characterize them?
Yes, okay. As I explained, like we can use welding processes for the 3D printing, but the major challenging task is like the toughness, and toughness is not reliable as like welding components. So in case of the printing direction, the grain growth is like a columnar grain growth. So the properties are much lower than actual component. So that's the reason we are using some kind of intermittent techniques like peening, otherwise cryogenic cooling. So those processes can improve the refinement and improve the mechanical properties. So currently the 3D printing technologies almost solved all the problems, and yeah, we can use them without any much complexities, I think.
Good afternoon, sir.
Yes, sir. Yeah.
Sir, my query related to design of turbulence for heat exchangers. Typically, when we design heat exchanger nowadays, people are employing different types of turbulators passive as a passive techniques. They're going for multiple configurations. Let's say twisted tap inside one wire coil with a different coil ratio like that. No, sir.
Yes, sir.
So when we would like to design these complex passive techniques, how these 3D technology can be utilized for printing, producing these kind of designs. Like, are these
Yeah.
3D
Yeah.
printing amicable for producing these, or we should go for the conventional method?
Yeah, there are some complex shapes can be printable, but coming to the quality aspects, still we don't have any qualified standards heat exchangers. So because inside these coils can be printable by existing 3D printing technologies,
Okay.
but those can be sustained during the operation, or their durability is still unable to predict. So that's the main issue. But until printing and in the research stage is no problem. We have technologies, 3D printing technologies.
So like we can adopt this metal 3D printing.
Yes, the laser-based 3D printing is most suitable for this kind of multi-complex component. Yeah.
Okay, sir. Thank you, sir.
Thank you.
There is a comments from chat box. Sanmukha Kishore Garu. Sir, printing in layers need pure material. His question is, printing in layers need pure material.
I mean, pure material means there is no classification in the material. The entire component uses the same material. But if I understand his question clearly, like if the materials is not pure or little bit contaminated, you will come up with some kind of defects between the two layers. So you have some contact issues, and the adhesivity will be poor if the any material is contaminated, which you use for the 3D printing. So not only the contact surface, the inside the layers also there might be some defects can be existing. Yeah.
There is another query, sir. What are the techniques that can be used for characterization of 3D printing material? Question from Krishna Varma Garu.
So yeah, if it is same characterization techniques what we are using for the conventional materials. Same, there is no specific methods. But there is one important thing is we have to use the computer tomography scanning to scan the entire 3D printed component, whether it has any micro defects inside the component. That is mandatory because the entire component is printing, so there is a chances of defect at any uh, area of the part. But in case of conventional one, we no need to be worry about entire component. Since it has any welded joints, you need to concern about only the joint parts. Yeah, except that CT scanning, other characterization techniques are same like conventional one.
Okay. There is another question from Narendra Kumar Garu. Sir, can we use this technology for the production of multi-layered composites for electronics?
Yes, sir, it's possible. Electronics components are also we are using these multi-layer components. There are, yeah, I think there is some participant Devalingam, but polymer-based 3D printing for hydrogen storage applications, I think may not be. I think because hydrogen storage needs, like very strong materials, probably metals, but I'm not sure that polymers can be used. That to 3D printing based, not yet reliable for hydrogen storage. Yes, this 3D printing is scale effectively for large renewable energy components like wind turbine blades and solar panels. Yes, solar panels is possible. Is already started the production and is available in the market also, but not in India. But wind turbine is not yet developed. It's still under the developing stage. Due to its complex shape and length, we have some restrictions to use this 3D printing technology for wind turbine blade. But if the blade length is small, it is possible for small scale wind turbines.
Hello?
Hello?
Yes, sir. Is it audible?
Yes, audible.
So, sir, one more thing, sir. There is a question from again. Can 3D printing scale effectively for large renewable energy components for wind turbine blades and solar panels?
Yes, not really, but one of the like technology solar panels is possible.
Hmm.
Those are already started the production, and they are 20% more efficient than the conventional manufacturing techniques. But
Okay.
wind turbines are not yet um, developed. The technology is still under developing stage.
Okay.
Yes.
Sir, one more thing, sir. What is the things we need to remind when we are going for a 3D printing of any component? So it's like any kind of checklist we have to follow or something like that.
So
Is it possible to any material can be printable or there is some constraint for the particular materials?
yes, there are some, not all materials possible. Still, some of the materials are unable to print. But the things need to be checklist means if you go for higher large scale component, the design for additive manufacturing, the starting of the component design should be compatible with your component, has to resist the distortion and residual stresses. So otherwise, you will come up with some kind of cracks and bending of the component. You will lose the actual geometry of the component. Yes.
But most of these 3D printing materials actually it is taking a lot of time. So how to reduce this time for printing time? So is there any like optimizing parameters which will be involved for this 3D printing process?
Yes. There are some processes like directed energy deposition for metals. Those are like 5 times more efficient than this laser-based 3D printing techniques. So still we are studying how to improve the productivity of this 3D printing. So as I mentioned that we are increasing the wire size from 1.2 to 3.4 diameter to increase the productivity. But it doesn't have any positive results, because when we go for higher diameter, we have some problems with the feeding and melting. So still it is under developing stage, improving productivity. And even if you have optimal parameters, maybe you can improve the quality, but not productivity, I think.
Sir, I have a last query from my side, sir.
Yes.
Pardon for me. Sir, actually, thing is that recently I just gone through some videos so that they are effectively printing that aerospace rockets also by using the 3D printing technology. But
Yes.
thing is that if you do the 3D printing process, that surface roughness is very higher. It is not smooth enough. So how to overcome this challenge, particularly for 3D printed materials?
Yes. So for this kind of sophisticated applications like aerospace, surface roughness is very important. So 3D printing alone is not enough. So we need to go for the post-processing methods to improve the surface roughness. I think.
Okay.
Yeah, after printing.
Thank you, sir. Is there any questions from audience side?
Sir, myself, Dr. J. Prabodh Kumar, sir.
Yes, sir.
Sir, as you mentioned that the 3D printing parts having the lowest surface finish, in order to overcome that, where we are doing some post-processing treatments. If we are doing that type of post-processing treatments, obviously the cost will become increases. Then how we can overcome those challenges? That means how we can reduce the products within the requirements of the customers.
Yes, not all components needed post-processing.
Yes.
Yeah, only like aerospace, not aerospace and space components
Yes, sir.
where we need specific applications. But in that case, you no need to consider the cost, because the
Yeah.
component cost and like safety concerns are more higher than the cost.
Yeah,
So
which means directly it will reduce the efficiency of that product, sir.
yeah, right. So those some of the sectors still, like 3D printing is not favorable to reduce the cost, but it is favorable to only reducing the manufacturing cost, not completely total product cost.
Yes, sir. Thank you, sir.
Yes.
Any questions from audience side? Okay. Uh, Thank you for your kind cooperation. On behalf of organizing committee and all the participants, I extend our heartfelt gratitude to our distinguished speaker, Dr. Murali sir, for delivering an insightful and thought-provoking lecture on 3D printing technology. Your expertise and ability to break down complex concepts into the practical insights have been incredibly enlightening for all of us. Your presentation not only highlighting the latest advancements in 3D printing, but also emphasized its transformative potential across various industries, inspiring us to explore its application in our own domains. We truly appreciate the time and effort you are invested in preparing and delivering such a comprehensive lecture. Your contribution will leave lasting impact on our participants as they apply these learning in their academic and professional journey. Once again, thank you for taking the time to share your knowledge and inspiring us with your vision. We hope to have a pleasure of collaborating with you again in the future. Thank you so much, sir. So, Dr.
Yeah.
Subramanian Garu, can you
Yeah.
you want to share anything?
Okay. Thank you, Dr. Murali.
Thank you, sir.
On behalf of MVZ College of Engineering and all the participants, I would like to extend my heartfelt thanks to you for taking time to share your expertise with us. Your talk on the role of 3D printing in sustainable energy technologies has been incredibly insightful and really inspiring. We truly appreciate your effort in making this session engaging and informative. Thank you once again for your valuable time and contribution to this session. Thank you so much.
Uh,
Thank
so
you, sir.
dear, dear participants, can you switch on your video so that we can take some snapshots for our records? And also, I already shared the information. You has to be attend the testing assessment test in the period from 7 p.m. to 7:30 p.m. So you has to participate. You has to enroll in participation login and complete your test within that 30 minutes period of time. So that questions pattern is uh, 20 questions, 20 question multiple choice question. You have to finish it off, and before that, there is a before 7 p.m. So we have to give that feedback also as well. So this testing as well as this feedback also both are necessary for generating your e-certificate in the ATAL portal. So don't be neglect all these two important things. This is very important task. You have to finish from your side. And if you have any difficulties you are encountered, you please share in that group so that we will try to resolve it. After assessment test is over, you please attend for the validated session also as well. Thank you. You please switch on your mobile video. Yeah. Yeah, please hold for 5 seconds. I'll take a snap now. Okay. So my job is done. So please be involved for next session. Okay, thank you. You can switch on your video. Sorry, switch off your video.
Dr. Ravi,
Yes, sir.
Sir is already joined.
Sorry, is already signed in into that Google. So we can continue, sir. Dr. Murli, sir, you can sign up into your session, sir. Okay, we'll move to the next session. Good evening, everyone. It is an honor to introduce an accomplished educator and researcher in the field of chemical engineering, Dr. Baburao Gaddala, sir, who currently serves as a senior lecturer in the Department of Chemical Engineering at University of Technology and Applied Sciences, Muscat. With a rich academic background, Dr. Babu Rao sir holds a BTech, MTech, and PhD in chemical engineering. His doctoral research focused on bioabsorption of heavy metals ions using marine macroalgae, sargassum, and bio algae materials, highlighting his dedication to addressing environmental challenges. Dr. Babu Rao sir brings over 17 years of teaching experience, demonstrating his commitment to nurturing the next generation of engineers and scientists. His research contributions are impressive, with 21 peer-reviewed journal articles, one book chapter, and 3 patents, some of which are under review. He has also presented his work at numerous national and international conferences in India, showcasing his active engagement in global research community. Dr. Baburao sir expertise is recognized beyond academia, as he serves as an editor and reviewer for several peer-reviewed journals, contributing to the advancement of knowledge in his field. His area of research interest includes water and wastewater treatment, bioabsorption of heavy metal ions, nanocomposite material, heat transfer process, and artificial intelligence techniques for various chemical processing technologies. He has been honored with sponsored research fund from the government of Oman, reflecting the value of his work in the solving critical environmental and engineering problems. Dr. Babu Rao sir holds membership in various national and international professional bodies, ensuring he stays at the forefront of emerging trends and innovations in chemical engineering. It is a privilege to welcome Dr. Babu Rao sir, whose expertise and dedication to research and education will provide valuable insights during the today's session. Please join me in giving him a warm round of applause. Thank you, sir.
Good afternoon, sir.
Yes, sir. You please continue the session, sir.
Are you able to hear me, sir?
Yes, yes, yes. Yes, sir.
Okay. Good evening to all of you. I think it's good afternoon for all. As I'm in other country, so now my time is 3 o'clock, 3:30, I think. India time is, and my time is 2 o'clock. Thanks. First of all, I would like to thank from NVGR management and also Dr. Subramanian sir and co-coordinator Dr. Ravikumar sir for giving me this opportunity, sharing my little knowledge to you. So I hope this lecture will help to you. So I'm going to give just very small information to you. So at the end of the session, we'll have some discussion if you have any doubts. Thanks for giving this opportunity once again to Dr. Subramanian sir and Dr. Ram. So are you able to see my this one, sir? And in between, maybe due to some internet connections or something, maybe some lag will be there. Please bear with me due to some internet problems.
Yeah, okay, sir. Now we can able to see your screen, sir.
So now I have shared the screen. Please confirm me, are you able to see my screen or not? Kumar sir, is it visible?
Visible.
Yes, sir. Yes, sir. It is visible, sir.
Okay, so thank you. So first of all, I would like to introduce myself. Thanks for introducing myself for Dr. Ravikumar sir. And once again, I would like to introduce myself. This is Dr. Babu Rao, Senior Lecturer working in Chemical Engineering and University of Technology and Applied Sciences, Muscat, Oman country. So today I would like to give some lecture on artificial intelligence and the machine learning models for the energy sector. So first I will give you some introduction and some information about the artificial intelligence. So then we'll go for the machine learning models. So as you know that nowadays all the sectors equipped with the new and updated softwares for the new learners and the new researchers, and it is irrespective of the specialization and irrespective of the works, all these softwares are interconnected. As you know that, so this is not specific to particular specialization or particular branch, something like that. Okay. So even though it is, so earlier we used to think that so the softwares or maybe the updated technologies will be applicable for only for the software. It cannot be for the other specialization like that. We have a thought, but nowadays, even though I belong to chemical engineering specialization, in all chemical engineering specialization and all research works, so these plays a vital role. So nowadays, without this works and without this application of these softwares, and our research could not be completed. So even in our research or in our PhD works, so somewhere this application is required. Okay. So like that much importance is there for this artificial intelligence. Even the artificial intelligence, it's old one, and then the new works, it is connected with the machine learning, and nowadays deep learning, artificial fuzzy logic, and artificial intelligence, and artificial neural networks. All these are playing a vital role. Okay. So in this, I'm going to give just only the small information about the related to the FDP program. So now I would like to start with the first. I'm going to start with the artificial neural networks. So then we'll go for the remaining softwares, and I'm going to apply for that. And I'm going to explain what is the role of these softwares, artificial neural networks and machine learnings, and how it is applicable and how it will be helpful for the energy sector. So that is the objective of today's session. So I'm going to start with the artificial neural networks. So how this will helpful for our research?
Sir, small request, sir.
Yes, sir.
Can you put your screen in full screen mode?
Yeah, sure. Now it's okay, sir?
Yeah, okay, sir. You please continue, sir.
Yeah, thank you. So I will start with the artificial neural networks. So first, how this idea, how the software has developed, and what is the help or what is the use of this software. So in our research work, and how it is connected with the daily life or daily life. So first thing is it's a software and it's a technique. So mainly you know that for any process, irrespective of the again I am going to specifying here irrespective of the specialization. So for any process, especially for the mechanical engineering students, so all non-circuits, I can say that non-circuit branches for any process, so should go for the model. Okay. So once we model the process, then we can apply some software. So by using different techniques. So not only artificial neural networks. So nowadays many softwares has developed. So first we develop the model, then we'll go for the optimization, then we'll go for the simulation. So the main purpose of this one is modeling, optimization, simulation is, so we are going to know so what is the performance of the particular system. So after assuming particular system, so we are going to study it, whether it works properly or not, whether it is giving a proper results or not. We need to check that. So that is called as a prediction of the performance of the system. So this one is mainly this software it's a data processing systems. So like it can be connected to our human body. So you know that our human body mainly function. So how many neurons are there in our body? So every neuron it has some different functions of it. Some elements or some components it will work as input signals, and some neurons it will work as output elements. So like that here also. So as you know that in our body neurons it will work as the basic elements, and it has some components of that. So it is a dendrites and the cell body or the soma and the synapses. So dendrites, you can take it as the input signal. So you know the main purpose of the dendrites. So input signals are nothing but what input you are going to give it to the system. So like that we can compare it to our research work. And cell body works like a processor. Okay, so after processing, so it will give you some output. So you will get the output to the axon. So like that we can compare our body with this software. Okay, artificial neural networks. And the next one is, so this software, it will works like a two ways, like our human brain. So one is for the learning the knowledge and the storing the knowledge. Okay, so like this, you can compare these terminologies with the software. Okay, so whatever it is, interconnected links are there. So this software connected to the software, it is called as a weights. Okay, what are the neurons or this input and outputs is connected in the software, it is considered as a, the term in the software, it is considered called as a weights. So generally, these neurons, it will receive the multiple inputs in the body, and it has some functioning is there. So here these functions are called as a non-linear activation functions, and it will give you the each function, it will give you some output data. So maybe it will go to or it will be connected to the other neurons. So like that, so each neuron, it will be connected to the different processes, and finally it will give you the different outputs. So we need to identify that what is our input data values. So based on it input data values, where it is forward or where it is connected. Okay, so that's what is considered as the neural networks, artificial neural networks. Okay, so how it is connected or how it is forwarded to the next layer of the network. So like this, you need to compare and you need to understand the software which is connected to our board. Okay, so now here I'm going to show the some basic figure to understand the complete understanding of the software. So this one is here I have mentioned some basic some inputs. Different types different inputs I have taken. So input one and the inputs it is representing with the I. So if I consider as the input one means it is considered as I equal to 1. And if it is 2 means input 2, I equal to 2, I equal to 3, I equal to 4. Like that I have mentioned here. So different inputs. Okay. So from input to outputs you have different hidden layers of it. Okay, so this hidden layers is represented with the G. Okay, so please understand these terminologies. Input terminologies representing with I, and the output terminologies are representing with K. In between, the hidden layers are representing with J. And from the input, so it is sending the information to the in between input and output. You have a hidden layer is that is sending to the different hidden layers. Okay. So if you say the I equal to 1, so from I equal to 1, the information is sending to the different hidden layers, then it goes to the output layer. Okay. So from input to hidden layer, it is representing with the WIZ, and at the bottom, it is representing with the BJ. So it is in between. So all the inputs or whatever the connecting inputs are there, it is represented with the BJ. And whatever the final outputs coming from the hidden layers, it is represented with the B. Okay. So from input to hidden layer, that lag is considered as a transit. That portion is considered as a transit, and from the hidden layer to output layer, it is considered or it is called as pure layer. Okay. So this is just a basic idea of this modeling, artificial neural network modeling. So based on this idea, we can calculate the required information or required values. So suppose if you want to calculate as a WIZ or BK values, so this can be calculated by using the standard expressions. So from you can observe here, so still for better understanding, so artificial neural network modeling, it is representing with the complete ANN is classified or splitting into two portions. One is feed forward neural networks. For the simplification, you can represent as a FFNN. Okay, so FFNN is nothing but feed forward neural networks. And the next one is the feed backward neural networks. So the complete artificial neural networks is represented with two methods, feed forward and the feedback. Okay, so we need to observe that. So what's the difference between the feed forward and the feed backward? So feed forward is, again, it is classified or divided into three portions or three layers. First one is the single layer perception, and the second one is the multi-layer perception, and the last one is the radial layer basis function map. Okay, so we need to observe that in the feed forward. So what is happening in all the three layers, single, multiple, and radial layers? What is happening, and what function it is exactly happening? And if you see the feed backward, so feed backward, and you need to observe the figures also. In feed backward, we have different networks are there, like the feed forward. First one is the Bayesian regularized network, and the second one is the Cohen's self group map, and the third one is the Hope-Field networks, competitive, and the Hertz modes, like that. It is divided into 5 regions. Okay, so just observe in both the cases, feed forward neural networks and the feed backward neural networks. So from the title itself, you can understand. So feed forward is nothing but whatever it is input you given to the process. So that will goes to the direct, and finally it is reached into the output layer. Okay. So initially it has the 3 input layers are there. So these 3 input layers are sent into the 4 hidden layers. And finally we are getting as a output layers of the 5 output layers. Okay. So like this, the process of the neural networks, it is connected like a forward direction. So based on the functioning or based on the modeling, the way of modeling in the feed forward, it's in a forward direction. So that's why this type of network is called as this type of neural network is called as a feed forward neural networks. And if you see the second one, just observe the second one. So here also the same layers are there. Input layer is there, and the hidden layer is there, and the output layer. So just observe the feedbackward layer, feedbackward neural networks. In case of the input layer, again I have 3 inputs are there. Okay, and the hidden layers we have only 2 are there, and finally we are getting the 3 outputs. So because within these 3 inputs and 3 outputs, the process should complete. So if the output 1 is not satisfying, again it should come back. So similarly for the output 2 is not satisfying, it should come back to the hidden layer and should go to the input. So like that, within the process, within the feed backward conditions, you should complete our modeling and complete the simulation. But in case of the feed forward, so whatever the inputs you are giving to the process will go to the hidden layers, and finally you are collecting the output layers. And first we'll discuss about what exactly is happening in the feed forward neural networks. So as I said that, if you see the previous slide, so complete artificial neural networks are classified into 2 types, feed forward and the feed backward. And the first one is the first I'm going to explain about the feed forward, multi-layer feed forward and neural networks. So why it is called as a multi-layer means you have a, if you see the previous figure, you have a 3 input layers are there, and the 4 hidden layers are there, and the 4 output layers, 5 output layers. Okay. So that's what is considered as a multi-layer feed forward neural networks. So here you can observe that mainly it is consisting of the 3 layers, input and hidden layers and output layers. So mainly from the input data is nothing but, so each neuron receives the input data from other neurons, and it passes to the hidden layer, and finally it reaches to the output layer, as I shown in the figure. You can see from. So this one is the input layer. It will receive the information from the neurons, then it will pass to the hidden. So then it will goes to the output layer. So like this. And the neurons, it is interconnected to the processing nodes and combined together, and finally make it as a artificial neural networks. And the output of each neuron is a result of the weighted set of the inputs. So the meaning of this one is, see here. So if you see the first input, so from this input, whatever the output it is coming as a 1, output 1 is nothing but from this input 1s through hiddens, and finally it is getting as a output 1. So like that it is connected. See, the output of the each neuron is a result of the weighted of the set of the inputs. So whatever you are giving the inputs, finally you can get it as a result. So this is considered as a multi-layer feed forward network, neural networks. and you can calculate this x value. So as you seen in the previous figures here, so I think somewhere it is there x value. So if you want to calculate this x value, weighted x equal to, so I equal to 1, I equal to 1 to n, wij into ai plus bj. So by using this equation, you can calculate the x value. And here n value is how many inputs you have given to the system. So that n value we can start from the 0 to n value 0, 1, 2, 3. And the wij representation is the interconnecting weights of the input data. So that is wij. And AJ and BJ are considered. BJ is considered as a bias for the neuron values. So once you know these values, you can calculate the x. And the knowledge is stored in the form of this set of the connections, connecting weights and the biases. So how many weights are there and how many biases are there? So it will be connected like this. And the transfer function, you have a transfer function also can be generated, and it is the sum of the weighted inputs. So the bias is the process, and output can be predicted. So this output values it is representing as a y, and it is equal to f of x. So f of f multiply with the previous value x value. So you can see from here. So some of these weighted inputs with the bias. Where I said no. So this BJ is nothing but it is a bias for the neutron, and this A representation is the input data values. So with this, you can calculate this transfer function values. So generally, this hidden and output layers, so it has some transfer functions or activation functions, so with which is a linear or non-linear. So you can take either the linear function or non-linear functions, and many algorithms also available. So to generate or to develop your input and output data values. So generally, this output lies between the 0 and 1 values. So the non-linear activation functions. And this non-linear activation functions is also called as, it has some general name is there. It is also called as sigmoid function. Okay. So whenever this sigmoid function is there, that is that you can consider it as a non-linear activation function. So as I said that if you see the first point here, so as I said that here this functions are, so this activation function or a transfer function, it is considered as either it can be linear or non-linear in the range of 0 to 1. And this non-linear activation function is called as a sigmoid function. Okay, so this transfer functions with the relation between the inputs and outputs. So here I have represented some general representation of the graphs, the sigmoid function and the tan H function, RELU and the RELU. So these are the different graphical representations for the different functions. Based on this one, you can choose which is suitable for you. So now I'm going to explain about the radial bias function. Radial bias function. So this radial bias functions. So here the activation function is called as a radial bias function, and the linear function is used at the output layer. You can see from here. So here input I have taken as a different x1, x2, x3, or and so on xn you can take it. And this hidden layer is considered as a radial bias neuron. So by using this Gaussian function, the transfer function by hidden layer is generally it is a Gaussian function. Okay, so here in between. So this hidden layer is considered as a radial bias neuron, and this can be considered as a Gaussian function. So by using this equation, phi of x, it is equal to exponential of minus of xi minus cj by 2 sigma j whole square. So by using this equation, you can calculate this pi values. So what is your hidden layer for the each connection? So from this pi 1 to this sigma value, you have w1, the weighted functions are there. So w1, w2, and so on. And the next one is feed forward back propagation method. So this method is widely used in the training the artificial neural networks, especially in the supervising the learning tasks. And generally, this method it has two phases of it. So if you see the previous one, what I said is here, this one. So what I said is this complete artificial neural networks are classifying as a feed forward and feed backward. So again, this feed forward propagation method, here you have two functions over there or two phases over there. So one is the feed forward phase and other one is the back propagation method. So that's why the complete the title is the method is called as feed forward back propagation method. Okay. So first we'll discuss about the feed forward phase. So what exactly is happening in the feed forward phase. And the next one is next phase is second phase. We're going to discuss about the back propagation method. Okay. So in the first case, so as I said that from the artificial neural network, basic figure also I have mentioned. So it has three layers. So one is the input layer, and the other one is the hidden layer, and the last one is the output layer. Okay. So generally the process is starting with the input data. So it is fed to the input layer, and this input layer is passes through. So based on your hidden layers, it may pass through one hidden layer or maybe more than one hidden layers. Based on that, you can give the numbering. Okay, so hidden layers, and this hidden layers, or it can be considered, or it will be calculated as a weighted sum of the inputs. Okay, and it applies to a bias. So you have some inputs are there, and it applies to the bias, and then it will result to some activation function. Okay, so what are the activation functions? As I said, and as I have showed you in the previous figures, so we have ReLU activation function is there, and sigmoid function is there, and tanh function. So to introduce the nonlinear activation, and finally this data, so from the input to the hidden, so then finally it will reach to the output layer. So here you will collect your data values, output layer values, and this neurons again it will perform as a weighted sum, and finally it will having the activation function to produce the network predictions. So like that you will you can run the programs, or you can solve the problems by using this feed forward phase. And the next one is back propagation method. So it's as I said that it is two phases. So once you finish this feed forward phase, then we'll go for the back propagation. So now we need to observe that what exactly is happening in the back propagation phase. Okay, so it involves mainly it is updating the weights of the network. So finally our objective is whether it is a feed forward or feed backward, so whatever it may be. So finally our objective is to minimize the error. Okay, so once you minimize the error, so then we can optimize the things. So then we'll go for better, we will get the better results. Okay, so to minimize the error between the predicted output and the actual output. Okay, so by taking different input values, so how exactly it is coming the output values, that is called as the predicted, and we have some required output values also. So based on that you can calculate, or first you can calculate the error. So if the error is too much large, so then you can change the again input values. Okay, then again we'll run the program. Okay, so like that. So then the back propagation. So you can observe the title also. So back propagation is nothing but, so once the giving the input values, you can have some output data values, calculate the errors, and again back propagate based on the value, based on the values. You can again you can go for the input, you can send your input values. So like that. Okay. So first thing is in case of the back propagation method. So first objective is calculate the error. Okay. So as I said that you need to observe it. What is your actual output value and what is your predicted output values. Okay. So this can be calculated at the output layer, because once you get the output layer only you can observe, or you can get it whether the errors are coming more or less, or what exactly is happening in the process or system. Okay. So by using the last function such as the mean square error, so we have different methods of that. So to calculate your error values. Okay. So one of that, it is called as a mean square error for the regression tasks, and the cross entropy for the classification tasks. So like that, it is based on the tasks and based on the required values. You can use any of the equations. So generally, the error measures the difference between the predicted output and the actual targeted values. So this point already I said in the first one. the error calculation. So then after that, once you calculated the error by using these standard equations and standard methods, mean square errors and this one class entropy methods, then we'll go for the gradients. So then this the error is then propagated so backward to the network to calculate the gradient of the loss function. So with respect to each weight, because from the you have different weights are there, so that weights you can calculate. So what is the gradient? Okay, so again here we have some different mathematical rules are there that is considered as chain rule for the calculus. So again starting from the output layer, and the gradients can be calculated by the layer moving towards the input. So this is the next step in the back propagation. And the last one is updated weights. So once the gradients are known, so first option is the calculating the error, and the second option is calculating the gradients, and the next one is the updating the weights. So this will be again it is interconnected with the gradients. So the weights are updated so using the optimization algorithms like a gradient descent method. Okay. So these weights are adjusted in the opposite direction of the gradient to reduce the error. So the learning rate and the hyperparameter and the control space of the size updates. So this is the method for the reducing or controlling the weight values, W values. Okay. And you have first you need to initialize. So generally in this method, the feed forward, the back propagation method, generally what is happening is first you need to initialize by taking some values. As I said that from the figure I have explained, you have different weights is there and the different biases are there. So first you need to take some values randomly. You can take it. So initialize the program and initialize the starting of the work. So once you initialize by giving some data values or from your process or some assumed values. In the first case, feed forward case, so pass the input values. As I said that in the feed forward you have input and you have hidden values and you have finally you will get the output values. So there will not be any back in the feed forward input. But in the back propagation, what is happening is from the output values, you need to observe it. So what is your predicted output data values and what is your actual data? So sometimes error may be happening. So that thing, that functioning, or that steps will be calculated in the back propagation. So that's why this together it is considered as one method, that is feed forward back propagation method. So as I explained in the previous slide, in the back propagation you need to calculate the error, then we'll go for the gradients and we'll go for the updating the weights. Because so why you need to update the weights? What I said in the first step. So in the initialization step, you need to take some random values of the weights and the biases. If the too much error is there from the second step here in the back propagation, so again you need to update the weight values. So I hope you understand this feed forward back propagation method. So here I will show you some calculations. So just by taking, as I said that in the first step, what I said, you need to start with the randomizing some values on some weights and biases values. So by taking some random values only, we are going to do some calculations. Okay. So feed forward method. So what is the feed forward method? What you have to do? First, you need to supply some input values. So this is your standard representation of your ANN. You need to represent some input boxes, and you need to represent some hidden layers. Finally, you should get some output. Okay. So for this output calculations, before getting your output values, first you need to calculate what is your hidden layer. Okay. So please observe this graph properly. You have two inputs of it. It's like a random values. So as I said that these functions also it is in between the 0 to 1. So I taken x1 value is 1 and taken the x2 value is equal to 0. And you need to observe the first step very clearly. So what I said is in the initialization, you need to randomly take some weights and biases. Okay, so now we'll go for the figure. So here I have taken the weight values. You can see here. So W1, W2, W3, W4, W5, W6, all these representing as weights. Okay. So weights I have taken some random values I have taken. So let's see later, once we calculated the output values, then we'll see how the errors will be. Okay. So this x1 value, this output input, first input x1 value, it is connected with the hidden layer 1 and as well as the hidden layer 2. So you can see the arrows very clearly, it is represented here. First arrow and the second arrow, and each connection to the hidden layer, it has some weighted value that is representing with w1 is equal to 1 and w2 is equal to 0.5. So because this is connected to the first input value and from the first x1 value, so I defined as a w1 and w. Okay, and from the second input, and this first, for the first input, it has some bias also, it is, so that is representing with b1 equal to 0.5. And similarly, for the second input, that is representing the circle representing with x2, and the value is taken as a 0. And for this also, it has some weights are there. I taken as a w3 equal to 1 and w4 is equal to minus 0. So I taken some random values, and this input also, it has some bias is there, that I taken as a b2 is equal to 0. Okay. So like that, I have reached up to here h1 and h2 hidden layers I have reached. So after hidden layer 2 output values. So in the feed forward method, 3 steps of 3 layers of it. One is the input layer, and the second one is the hidden layer, and the third one is the output. So from the hidden layer h1, it is reached into, finally you should get some output data values. Okay, you need to calculate or you need to get the output value that is represented as a y. Okay, so I hope you all symbols you understand. X1 representing as input data, first input, x1 is representing input 1. Okay, and the second representing as input. Okay, similarly, one representation is a hidden layer 1 and the 2 representation is a hidden layer 2. So from this you will get it as a one output. So I'm going to calculate as a output 1. Okay, and it has some bias is there, that is b3 is equal to 0.5. So now you need to understand that how to get the values of the hidden layer, because so you're giving some input and input values. So finally, to get this output data values, you should know how to calculate this h1 and h2 values. So hidden layer 1 and hidden layer 2, you should know the calculation. So from the connections also you can understand easily. So just observe that hidden layer, it is connected from the input 1. So how many values it is connected? It is connected with the input 1. From the input 1, just observe it. So what values it is connected? x1 and w1 it is connected. Okay, plus, and x2 also connected. x2 and w3 also connected. Multiply with x2. So x1 and w1 it is multiplied plus x2 and w3 it is multiplied, and plus bias also should be added. So what is the bias value I have taken? b1 is equal to, so later I will explain you the substitution. So similarly, just observe the next second layer also, h2 also. So please observe what are the things it is connected. So x1 and w2 is connected, you can see from here. So this is our input value x1 and w, this layer you can see from here. Okay, so x1 and w2 is connected, and x2 w4 also connected. Okay, so in addition this one plus b2 bias value is also connected. Okay, so like this, if you know the understanding of this figure with the knowing the known values of the weighted values, and with the known values of the input values, and with the known values of the bias values, so we can substitute to these values. So what is our x1 value? Here what I have mentioned, x1 values, it is input value, multiply 1, I have substituted here, 1 into w1, and x2 into w3. So what is our x2 value? x2 value is 0. So 0 multiply with w3 plus b. So I will substitute this w1 and w1 later. So what is our w1 is 1 and the b1 value is 0.5. So h1 value equal to 1. So like that you can calculate, or you will get the hidden layer 1. So similarly for the hidden layer 2 also you can calculate. So just observe the hidden layer connections. So hidden layer, it is connected with the x1 W. So already equation available here. So just substitute the values. What is our x1 value? X1 value is 1. And what is our W2 value? 0.5. So we'll substitute later. So here 0.5. And anyway, this x2 value is 0. So the second input I have taken as a 0. So then we can neglect this part and plus W. So H2 is equal to W2 plus B2. So you know the value of the W2 and you know the value of the B2. So W2 value is 0.5 and B2 value is 0. So finally, the second hidden layer is 0.5. Okay. So just by adding H1 value and H2 values, 1.5 and 0.5, then you will get it as the output values. So like this, you can calculate your output value. And here we are going to take some function value. So that is considered as a RULU, so activation function. So RULU function is nothing but it is the full name of the RULU is called as rectified linear unit. So I'll explain what is the meaning of this rectified linear unit. So it is one type of the function, activation function. So you can define like this: f of x is equal to x value is greater than 0 and x value is less than or x greater than or equal to 0 by x less than or equal to 0. Okay. So this the way of representation is called as a rectified linear unit activation function. Okay. So from the previous calculation, from the previous slide, you can see here the hidden layer you have a h1 is 1.5 and another the hidden layer h2 value is equal to 0.5. So in the second slide I have mentioned here h1 is 0.5 and the h2 value is h1 is 1.5, h2 value is 0.5. Okay, so you can calculate your y value. So y cap is equal to h1 into w5. So you can see from here. So again, this calculation h1 is multiply with the w5 and h2 is multiply with w6, and again this it has another bias is there. Okay, so for a hidden layer you have one bias is there. For the hidden layer 2 you have another bias is there, and the hidden layer next output it has the bias is there, that is B. So now I am going to connect all these things: h1 w5, h2 w6 plus bias. Now you can see the substitution value. From the previous calculation, h1 is 1.5, w5 already it is there from the figure 1 plus h2 value is 0.5 and the w6 value is 1 and the b3 value is 0.5. So this value is 2.5. And the L value is linear unit where L is calculated as 2.5 minus 2.5. So this is our, so as I said, no. So we have actual output value is there and the predicted input, predicted output values are there. So this, the difference 2.5 minus 2 whole square is equal to 0.5. So that is about the feed forward method. So now what you have to do is back propagation method. From the previous calculations, you got your L value is 0.25. And this L value also have some equation is there. L is equal to h1 into w5 plus h2 into w6 plus b3 minus y whole square. So by using this equation also you can calculate your L value. So now what we have to do is, so in the feed forward method, you just given our input value and from there you calculated the hidden values and from there you got the output values. So from the output value you calculated the L value. So once you know or once you compare with the actual output and the predicted output values, so we need to, if any error is there, you need to go for again propagation, back propagation. So in the back propagation, we have 3 steps only. So what are the 3 steps? We need to calculate the error, then calculate the gradients, and finally the last one is, so you need to update your weights and bias. Okay, so now what I'm going to do is I'm going to update the weights and the bias values. So now the differentiate with respect to the W5 from the previous equation dou L by dou W5. So just observe this equation H1 into my W5 plus H2 into W6. So after differentiation, we'll get this equation. So 2 into H1 into this equation. So after that, from this, you will have some dou L by dou W5 value. So from this equation, you will get, so after calculating this dou L by dou W5, we can calculate the W5 value. So this W5 value is 0.985 after substituting these values. Okay. So that is the one way of calculation for the updating your W5 value and W6 values. So similarly, again from the previous equation, from this equation, this is our basic equation to update our weight values and the bias values. From this, again you can subtract, you can differentiate with respect to the W6. So now I'm going for the calculation of the W6. So again, first you need to differentiate the value with respect to the W6. So this is the way of calculating your W6 value and updating your another weight value. So this W6 value is 0.995 and W5 value is 0.985. So this is that is the way of updating and getting your W5 and W6 values. So that weight values are updated. So what is the next value you need to update? Again, just observe this equation here from the L equation. So from the L equation, so we have W5 updated and W6 updated. So now we are going to update the bias value, because in the back propagation method, so we need to update our weight values and you need to update our bias value. So what is the bias value here? B3 is the bias value. So for that again, go for the differentiation with respect to the B3. Okay. So now we can observe here. So this is our B3 value. So again, same procedure. So the way of calculating for the weights and the bias is the weight. So for getting the weight value W5, you differentiated with respect to W5. For getting the W6, the new value or the updated W6, you differentiated with respect to the W6. So similarly for the bias also you have only one bias is that is B3. So what you have to do, follow the same process. So you need to differentiate with respect to B3 value, then calculate the updated bias value. Okay. So for this just differentiate and you will get the equation, substitute the values and the new bias value, so the new B3 value is 0.4. Okay. So after that what you have to do? So find this dou L by dou H1, calculate the dou L by dou H1 value and you will have some value that is dou L after substituting the updated values, you will have dou L by dou H1 is equal to 1. And to calculate the new hidden layers H1, so we need to multiply or you need to take, you need to use this equation RULU equation function. Okay. So by using this equation, you can calculate or you can get the H1. So for the dou H1 by dou W1, you have equations. You can take this U value is equal to W1 plus V1. So in terms of the you can define your RELU equation function, and by using this equation, you can calculate the H1 values and the W1 values. So now you can see here some expressions I have given dou H1 by dou U and the dou H1 by dou U. So these are the standard value. This is our equation. So W1 plus B1 is greater than 0 and W1 plus B1 is less than or equal to 0. So based on that, you can substitute our values. So W1 plus B1 is 1 plus 0.5 and 1.5 is greater than 0. And after substituting, you can calculate your dou L by dou W1. So with the help of these relations, dou L by dou H1 and dou H1 by dou W1. So we already calculated from the previous. So you can substitute these values and you will get it. So after that, what you have to do is you need to calculate the new W1 value. Okay. So follow the same process like the previous calculations. From this, you will get the W1 new weight value. W1 is equal to 0.9. So similarly, you can calculate the W2 also. So like the same process previously. So for this, again, you define the functions, this RULU function, and calculate the new W2 value. So this is your W2 new weight value. Okay, you have a W1 value from the previous calculation. W1 is equal to 0.99. And from the previous calculation here, we already calculated the W5. W6, B3 value, then W1 and W. So now you have already you got all updated values with the weights and the biases. So then you can calculate. So and again here dou L by dou H2. So again I use the same relations like the previous, and you can calculate over this one values. And finally, and here you got the new bias values, B2 values 0. Okay. So similarly, you can calculate the other bias values and other weight values also. So I have showed the calculation for the W1, W2, W5, W6, and B3 values, B3 and B2 values. The remaining calculations are W3 and W4, B1 calculations. You can follow the same procedure. So to get the updated new values, W3, W4, and B1. So after the first iteration, because you have updated your values, so after the first iteration, so again you can need to substitute your new values, again run the program. Okay, so this is your after the first iteration. So now what you have to do is I'm going to give like a flowchart type in the artificial neural network modeling. So first what you have to do is you need to start the process. So then identify the what are the input values, and with respect to input, what is your output responses or output data values, and the extraction of the experimental data values. So you'll have experimental data values, and you can compare with your program, and normalize the values. If it is normalizing, you can take some values range, and if it is not normalizing, means again you have to go back and check your experimental data values. And in the data partitioning, you need to check so training and the testing, and after that validation. Okay. So select the number of the hidden layers and the activation functions based on your number of the hidden layers and based on your activation functions. So next you can vary your number of neurons in the hidden layers, and choose some training algorithms. If any errors are there, so you know the error calculations. So if it is errors are available, so then testing and validation of the network. And whatever the model it is there, ANN model, so ready for the evaluation. If it is no errors are there, then you can go for here backside. Okay, varying the number of the neurons. And if it is S means again you have to go for the validation and the evaluation. So this is your simple MATLAB code for your ANN program. So by running or by simulating, by using this coding in the MATLAB, so we'll have the complete data values and the programs. So this one you can calculate here B1, B2, B3 values. So you already know the process for the calculations. From this also you can get your data values. So this is about the ANN modeling. So now we should go for the data preparation. Okay, so this is the main step and the crucial step in the this one data analysis and the machine learning pipeline also. Okay, so mainly in the data preparation here you have mainly cleaning and transferring and organizing the raw data into the usable format for the analysis, because for before going to the simulation or the running the program, so this should be in the proper format to do the analysis. Because if you see the previous figure here, so here I have mentioned that you need to go for the analyze your data values to by using the ANN model. Okay, so data quality improvement. So mainly the main purpose of these steps is we need to improve the data values, data quality values. So first you need to observe that if any missing values are there, so just observe that what is the gap values, and if any duplicate values are presented in your experimentation or maybe in the final results, you need to observe that, you need to identify that any duplicate values, and you need to correct the errors also. So sometimes typos will be there, sometimes incorrect values are there, sometimes inconsistent values are there, or inconsistent formats will be there. So these things you need to observe that to get the quality data values. So first thing is, so if any missed values are there, so you need to check that. You need to identify that and you need to manage. So if any gap is there from the data values, from the input data values, you need to check. And if any duplicated values also there, you need to identify and remove it. So finally, you need to calculate the errors. So that is the way of improving our data quality values. So next one is the value should be consistency, and it should have it should have standardized formats and the standardized value should be there. Okay, so you have some different uniform formats are there. So you need to check that. You need to normalize the values and the data transformations and the reducing the noise. Okay, so first thing is, so what I say, first thing is you need to check the proper formats, because from the different sources you may take the data values from the different sources. So when you are taking the different sources, so the formats, the data formats may be varied. Okay, so we need to check that what is the actual format and what are the standardizing formats. Okay, so for why it is required, the standardizing format is nothing but to maintain the accuracy or to maintain the consistency mainly. Okay, so examples are dates are there and the currency is there. So currency is there means for different currencies, different units are there. You need to check that rule. Okay, and the next one is the normalization. So you have some numerical data is there. So you need to write and you need to mention like a standard range. Okay. So mainly it is helpful for the algorithms. So to run the programs. And the next one is the data transformations. So data transformation is nothing but sometimes the program may not understand our data values. You need to convert into the suitable format or maybe sometimes suitable structures also. Okay. So transferring the non-numerical data into numeric. So like encoding the category variables. And the last one is the reducing noise. So cleaning the data helps in reducing the noise, and if any irrelevant information is there, so that can be eliminated. So this is also one way of improving or enhancing the accuracy of the analytical models. Okay. So these are the 4 steps for to maintain the quality data values and to get data consistency and maintaining the or standardizing the data values. Okay. So these are the steps. So here I have mentioned represented in the photo. So first you need to load the data values and you need to drop the columns that are not useful. And the second one, next one is the handling the missing data. So what I said here, in the previous thing, here first you need to check that if any data is missed, you need to identify that. So if any duplicates also there, you need to identify and remove it. And if any errors are there, you need to check that. So after identifying the missing data, then check the duplicate values. So if any duplicate values are there, so that duplicate values also you need to identify and then remove it. Okay. And the next one is we need to split our data values. Maybe some data can be split it into to run accurately. And the feature scaling, then the so this is again it's a cycling. Load the data, drop the columns, and check the missing data values. And the next one is normalization. So you need to check this. Finally, the data should be normalized. So this is also one of the important step in the normalization. Okay. So the the main purpose or the primary purpose of this normalization is why you have to normalize is nothing but. So you need to transform your data into common scales. So common scales are nothing but in a understandable way. So maybe in in a specified ranges, because some data should be mentioned or some data should be available in a specified ranges only. So within that ranges of the values, it can understand easy. Okay. So the another purpose of normalizing the data is it improves the accuracy of the results. Okay. And another this is one of the advantage, and another thing is convergence also. So quick convergence also possible. So we have different techniques are there to normalize this data values, because so normalizing what I said is normalizing is nothing but to get the accuracy data values and to improve the convergence values. For all these purpose you need to go for the normalization. Okay. So for this you have methods are there. So one is the minimum rule and the maximum rule. So with respect to your input and output data values within the range of the 0 to 1. Okay. So this accuracy or the standardization can be calculated by using, you have standard equation is that. So A minus A minimum by, so A maximum minus A minimum. So high value minus low value plus low value. Okay, so this is one of the method to calculate your standardization methods. And the next one is the data randomization. So this is also one of the crucial step for the several reasons. So first thing is, so you need to reduce the bias values, and the next one is improving the generalizability and preventing over filtering, overfitting, and ensuring the independence and validating the model performance. For all these reasons, so you need to the data randomization is required, and improving the experimental validity and simulating the real data scenario. Okay, so for all these reasons, randomization is important. So first thing is reducing the bias values is nothing but, so you need to ensure that your data values are representative and free from the systematic bias. So this is one of the important to reduce or reducing the bias. And the next one is the improving the generalizability. So generalizability is nothing but if any unseen data is there, so you need to improve it. Okay, so then preventing the overfitting, so stops model from the learning patterns specific to data order, so rather than the data itself. Okay, so like this, we have many reasons are there for the data randomization. So here you can see the data values. So we have a raw data is there, and the data randomization values and the data splitting values. Okay. So from the training you will get the 80%, and from the testing you have 20%. So now we can see the ANN modeling. So I have taken for the different PCM materials. So if you take it as a different types of the PCM materials, and you have different heating rate, like so this input and output data values is compared with taken as a process model. So like if you take it as a different phase change materials, and if you take the different heating rate and the different temperature values, so how the output values, so from this figure you can understand. Okay, so PCM is one of the input, and the heating rate is another input, and the temperature is another input. Okay, so PCM is nothing but a phase change material. Suppose if you take a one particular phase change material, so that is considered as one of the input. Okay, and the second one is heat rate is nothing but you are going to fix some heating rate, and for a particular temperature. Okay, so with this finally what is your heat flow? So this is my required output layer. So with this inputs, and I have some hidden layers are there. Like the previous calculation I mentioned H1, H2, H3 like that. So here also n equal to 1, n equal to 2, and so on, different hidden layers are there. So by using this weighted values and by using the bias values, you can calculate this hidden, and finally heat flow can be calculated. Okay. So for the portion of the input to the hidden, it is called as a transit, and from the hidden to output is considered as a loop. So now we can see the validation values and the training values. You can see with your R square values or values. Training and testing, as I mentioned here, from the 80% of the accuracy, here 80% I mentioned in the previous graph, previous values, and testing is 20%. And you can see the graphs representation with the output values, and have target input values, temperature values, and the heat flow also you can observe here. So this black graph representation or representing as a predicted data. You can see from here. So this almost this ANN predicted data and experimental data is almost, it is similar to the same. It is almost coincide. So there is no too much variation here. Okay. So that the error deviation of the predicted melting temperature and the latent heat of NN experimental values are so 0.0001 percentage and 0.95 percentage. Okay, so temperature variation and the latent heat of artificial neural networks. So this is my data values, and if you go for the sensitivity analysis, so once you finish your this one modeling and the data preparation, so then we'll go for the sensitivity analysis. Okay, so here you need to consider that in ANN models, so several parameters are mainly particularly sensitive, and it can be significantly influence the performance of the outcome of the model. Okay, so you need to observe that. So mainly, as I said here, so sensitivity parameters, by changing the several parameters or nothing but suppose here, if you choose the one phase material, the output may be different. If you choose the another phase material, the output may be different. And similarly, this another input also. Suppose fix the same input, fix the same PCM value with the different values of the heating rate and the temperature. So like that, so even if you change the 1 degree centigrade of the temperature also, this heat flow will be different. So that is the meaning of this sensitivity analysis. Okay, so here several parameters are particularly sensitive is nothing but mainly based on the input data values. Okay, so next one is the learning rate. So mainly it is determining the step size for each iteration. So for each iteration is nothing but by changing the different input values. Okay, so moving towards a minimum of the loss function, and a high learning rate can cause the model so to converge quickly, and the too low a learning rate can result in very slow convergence. So this is about the learning rates, and you can calculate the number of layers, hidden layers, and neurons also. Okay, so this number of neurons in the hidden layers, by using this equation you can calculate. So HN is nothing but number of layers, neuron layers, hidden neuron layers. Inputs plus how many inputs are there? Inputs plus outputs by 2 plus root of the train data. So using this calculation or using this equation, you can calculate the how many hidden layers can be maintained or can be mentioned in the figure. So you know that figure, no? So input should be there. You can just observe this way. So here you can see. So you have inputs are there, and output, how many outputs you are going to get it. So based on this neurons in the hidden layers can be calculated. So this n equal to 1, 2. So all these can be calculated by using this input plus output by 2 plus root of the train data. So this is one of the, before running the program, you can calculate this value, and based on that you can identify that how many hidden layers can be maintained. Okay. So this is about the sensitivity analysis, and I have some activation functions also there. So as I said that we have many activation functions are there. So it can, so again it based on this activation function also, so it will affect the model's ability. Okay, so and also affect the convergency properties also. So improper activation functions can lead to the issues like a vanishing or exploiting the gradients. So if you suppose, if you're unable, if you're not choosing the proper function, so as I said that suppose if you run the program or if you take the nonlinear this ReLU function, it will show you some values, and if you take the sigmoid, it will show you some values, and if you take the tan H functions, it will show you some like that. So there will be some convergence in terms of the convergence, and in terms of the errors also some problems will be there. So we need to check that the selection of the activation function is very important. So otherwise what will happen is these problems will be taken place. So some gradients, exploiting the gradients, or maybe errors may be more. So like that. So this is very important for the selection of the this one. And the next one is the batch size. So you need to check that what is your batch size should be there, and the number of the training samples processed before the model's internal parameters are updated. So you need to check that. So smaller batch sizes can lead to the noise or updates, and but it can be helpful in the generalization. And if you take a larger batch size, it will be more stable data values, and also accurate gradient values. But it requires some more memory, and it may go for slower training also, maybe possible. So like that, based on your requirements and based on the programming and based on this one, you can choose. So there are small batch sizes or larger batch sizes, you can choose. Okay. And the next one is the epochs, and you have weight initializations also there, and you have loss functions are there. So we need to choose, we need to observe these things also. So in the sensitivity analysis, so you need to check the epochs, number of the complete passes, and in the weight initializations also check the starting values are important. And the poor initialization can lead to the slow convergence or getting stuck in the local. So means what, we have calculated the different by after first trial or first iteration, we have calculated the again to calculate the new weight values and the new bias values. So that representation is the slow convergence. So that's why you need to check the proper starting values for the weight and new bias values. And the next one is the loss function. So loss function is nothing but it is almost near to the calculation of the error values. So we need to check the difference between the predicted and the actual values. So to get, and it will helpful for your optimization. So in the first point itself, I said that first you need to go for the modeling, then simulation optimizing, then go for the simulation. Okay, so these values, it will helpful for the optimizing the values. Okay, so the choice of the loss function should align with the specific requirements of the regression tasks. So mainly the common loss functions including the mean square error and the mean absolute error. So we need to check. So by using these standard error calculation methods, mean square error and the mean absolute error, you can calculate and you can go for the optimization methods. So here I mentioned, so read mean square errors and the absolute errors by using this equations you can calculate. Okay. And this will helpful for your helps you to guide and to run the optimization values. So mainly the significance of the calculating the statistical indices are. So finally you are going to summarize the data values and comparing your data values with the experimental values, identifying the patterns and trends. So how the graphs are coming and how the trends. So how the actual trend and from the running the program or from your programs also you can observe it, how the trends and how the patterns you can identify easily. Okay, and measuring the relationships also. So with respect to the temperature, how the heat flow, and with respect to the changing the phase material, so how the output values, and also with respect to the this one value in the initial flow rates. So making the informed decisions and the statistical inference and the model validations, all these will give you the importance. So here I have mentioned, so neural network model by taking the different models. So what will be the training values and what will be your testing values? So just observe from here. So in the training mode, so I taken as I calculated RMSE values and the R square values. So RMSE is nothing but root mean square error values, and R square is nothing but a regression coefficient values. Similarly in the testing also. Okay. So here network topology and the activation functions. I taken the activation functions. First one as a tan-seq, and here some functions of the log-seq also I have taken, and I observed up to network 1 to different 18 networks I have taken from this. So the R square value, so it is higher in the network 7. So you can see. So just observe the even error also, RMSE value also. So it is very less in the in the network 7, and the R square value is 0.9985. Even the testing also. Okay. So RMSE value is 0.0540, and the R square value is 0.9971. Okay. So network topology is 3-361, and the activation function here I have taken as a fancy. So this is about the validation of the results. So from the data you can observe that. Okay. Or from the calculation also you can see from here RMSE equations and R square equations and MAP equations. So now we can have some limitations are there for the ANN models. So as of now, we have discussed how the data importance and the sensitivity analysis, calculations of this weights and bias. And you have some limitation. First one is the in terms of the complexity, computational complexity, and the requirement of the data values. Okay. So first thing is the in terms of the computational complexity. So first one is the training time is one of the complexity, and the second one is the resource intensity. Okay. So in terms of the training time it requires deep networks, and it requires the computational resources and the time for the training, particularly with the large data values and the complex architectures also. So it has one of the complexity. And the next one is the resource intensive. So resource intensive is nothing but it requires the high performance hardware requires. So this is one of the limitations in terms of the computation complexity. And another limitation is another limitation is the large data requirement. So first one in terms in large data requirement, first one is the data hungry, and the next one is the quality data is also another important limitation. Okay. For third limitation is risk of the overfitting, and due to their high capacity to learn, so it has some complexities there, and the scalability of the issues are sizing. So model size, as I said, that small size and larger sizes, you need to check that the model size also. And this training time is also it will take, or so if you go for the very large data values, it will run to long training times. Okay. So this is another issue or another limitation with respect to the scalability. So scalability is nothing but suppose if you change from the side changes, so it will affect again the training time. Another limitation is so hyperparameter sensitivity. So tuning is required in terms of the hyperparameters. So what are the parameters are mainly here? The tuning parameters influencing the learning rate. So I explained in the previous slide how the learning rate and the number of layers and the number of neurons and the activation functions. So we need to check that. So how the learning rate is influencing your sensitivity analysis. Okay. So I explained the sensitivity analysis, many parameters are influencing, and the number of the layers also, number of the layers and the number of the neurons and the activation functions also. So if you choose I said this point also, if you choose the different activation functions, it may lead to instability. Okay, or maybe errors may be different. So we need to tune the parameters very carefully. Okay, especially these parameters. If you go for the improper settings, so maybe the performance will be very poor or suboptimal performance will be there. And in turn, so we will get the optimization values also will be complex optimization will be taking place. So finding the optimal hyperparameters often involves a so extensive experimentation and the computation efforts. So that's why always especially these things. So these hyperparameters, learning rate, number of layers, and the number of neurons and the activation functions. So when you're running this active ANN, so you need to focus mainly on these parameters. So if you choose properly, so you can minimize all the things. Even you can improve performance, and also you can improve the optimization values. Also, it can be. So that is about the artificial neural networks. And the next one is the hybridized neural networks. So hybridized neural networks is nothing but it is so suppose if you go for any biomaterials or bio-inspired things, then so you have a hybrid is nothing but by adding something. Okay, so by adding some another algorithm, then it is called as a hybrid neural networks. So you can see the figure. So you have as of now you have some idea about the ANN model. So if we add some another extra addition of the new algorithm or new optimization technique, so that is called as the bio-inspired optimization technique. So then the new name is called as a HNN, hybrid neural networks. Okay. So hybrid neural networks, so it has the combining the different types of the neural network architectures, or also it integrate the neural networks with the other optimization techniques. So anything you can take it. So either neural network architectures or neural networks with the optimization techniques. So it will give you the, or it will improve the overall performance. Always, if by adding the another extra optimization techniques, so always performance and the results and this one will be works will be very high level, and it will give you the more good performance. So mainly the purpose or the why you should go for this one. So hybrid network. So as I said that by improving the performance, our objective is, so with ANN you are not getting the still good performance. If you go for extra optimization techniques, then will improve the performance of the process, or the overall performance can be improved. That is our motto, or that is the technique behind this one. Okay, so mainly the idea behind is to create the more versatile and the powerful models by taking the advantage of the unique capabilities of the different methods. Because if you go for the optimization algorithm, many optimization algorithms are there, many techniques are there. So with the help of these optimization techniques plus ANN, you will have a more versatile data. The powerful models can be developed. Okay, so this method mainly, so it uses the bio-inspired algorithms to optimize the various aspects of the ANN values. Okay, so that is main intention and the main objective of this one. So we have several bio-inspired optimization algorithms are there. We have several bio-inspired algorithms are there. One is genetic algorithms, and the other one is particle swarm optimization. Like here, many algorithms I have mentioned. So from this, you know that the main thing is, so genetic algorithms, you know, from where this is a famous method, genetic algorithms, and we have another methods also there, but the known one is the genetic algorithms is the known one, and many people they are using for the research purpose. So something like that. So mainly,
Sorry for interruption, sir.
yes, sir.
So we have only 10 minutes of time. Can you quickly summarize the topic?
Yeah, sure, sir. So I'll give some brief about these methods, genetic algorithms, and I think we have fuzzy logic also there. So I will just give the overview. Okay, sir. So mainly this genetic algorithm is one of the optimization algorithm. So mainly it is connected with the population size, how much population should be there. So like that, these things will be there. You can see from the figure. So we have a selection of the method, then the replacement, evolution, mutation, and crossover. So these terminologies will be going to use it in the genetic algorithms. Okay.
ఒక 10 నిమిషాలు వెళ్ళిపోతాను నేను 10 నిమిషాలు.
So mainly this method is used to find out the optimum values. So to get for the complex optimization problems like the principles of the evolution, and including the selection, crossover, and mutation. So whenever this population sizes are here, so you can go for this genetic algorithms. So mainly in the key components of the genetic algorithms are population, fitness functions, and the selection. So you need to choose the proper selection and the proper population. Mainly it is based on the individuals and the chromosomes. Okay, so now I'm going to just skip all these points. So just I'm giving the key components only in the genetic algorithms, population, how to choose the population, and what is your fitness function, all these things. And as I said that in this genetic algorithm, mainly you need to focusing on the what is your crossover functions and the mutation and the replacement. Based on that only this genetic algorithm is dependent. So now I'm going to explain this slide, because by seeing this slide you can understand still better. So as I said that, so mainly focusing on this genetic algorithms, it is like our human population. So based on the chromosomes, this population will be different. So you can see here parent one, like mother and father. Parent one, it has some, you can see from the A to Z, A, B, C, D, F, G, H, like that I have mentioned here, and the parent two. So by combining this parent one and the parent two, so we'll have a offspring. So you can see here B, C, D, E is replacing with the this one. So FGBCD is the parent one, and the parent 2 is FGH. You can see from here FGH is first it is formed, and BCDE. And before mutation, FGH and BCDA is there, and after mutation, so FG and this H is replaced with the M, and the A is replaced with the M. So like this genetic algorithms will be taking place. And typically the neural networks, you have major challenges are there. So especially for the learning rate, lower learning rate, and being trapped into the local world. So I'm going to skip this one. So now I'm going to explain in a flow sheet way. So then you can understand how to follow the steps. Like ANN, artificial neural networks. For the genetic algorithms also, we have some flow sheet way understanding is that. So you can start by giving the data values, then determine the neural network topology. Okay. So once you determine your topology, so this one I already showed in the, you can see from the table here. So you have a table for topology here, network topology. So like this, here you need to choose the network topology. So this one, determine the neural network topology. So then you need to encode the weights and bias of the neural network to initialize the population. So you need to give some neural network weights and bias values, then decode the weights and biases. So to understandable. Okay. So then assign the weights and bias to the neural networks, then train the neural networks using the training data. Then you can go for the test the data. Okay. Suppose after that, you need to calculate the error by using the methods. So after calculating the errors, then check that the calculation of the fitness, then crossover, mutation, and the new population. So here these things are there: crossover, mutation, and new population. So whether that termination condition is meet or not, you need to check. So if it is a meeting, then decode the data to get the data, or decode to get the optimized weights and the bias values. So here, if you're satisfied, or if then this condition is satisfied, then you can decode it. So if it is not satisfying, or if it is not meeting your data values, what you have to do again, you should go for the weights and bias. So this one already explained in the previous slides also. So as I said that we should go for the new weights and the bias values after first iteration. So the same thing, mainly the new thing is, after calculating this error, you need to check the calculation of the fitness, then check the crossover condition, mutation, and check the new population, because you are going to change this crossover and mutation. So from the different parents, this will be changing. Again, new population will be coming. Check the condition. So like this, you can give it as a flow sheet for the genetic components. Then population size, you can calculate crossover, and the mutation rate, and the termination criteria. All these things, since like in ANN, you have a sensitivity parameters and the genetic algorithms also there. So first sensitivity parameter is the size, population size, and crossover rate, and the mutation rate, termination criteria, and encoding the scheme and the representation. So like in the figure, so here I mentioned crossover rate, then the mutation and the new population. Similarly, here you can see from here, crossover rate. First you do the calculation for the population size, then crossover, and the mutation rate and the termination criteria. So then encoding your data values with the satisfied data values. And it has some limitations are there, similar to this ANN. And no guarantee of the global optimum in case of the genetic algorithm methods. And there is a complexity in the computations. I think this point is similar to ANN. And we have some challenges in terms of the encoding the data values and the representing. And sensitivity, in terms of the sensitivity parameter sensitivity also we need to take care. And the premature convergence is there. And we have some limited handling of the constraints. And the scalability issues are there. And the last one is, last main limitation is the domain specific knowledge requirement, because since it is connected with the, so here I mentioned it is connected with the crossover and mutation rate, no, so that complexity is the major thing. So domain specific knowledge requirement is main thing. So these are the main limitations to the genetic algorithms. And another algorithm is the particle swarm optimization algorithms. So I think with the permission of Dr. Ravi Kumar and Dr. Subramanian. So can I continue, sir? Because still you have only 3 minutes is there. This is another algorithm. No?
No, sir,
Particle,
actually,
yeah.
expert is waiting for the next session. So
Okay, sir.
there
Then
is
no
some
problem.
time
So
constraint.
I will stop with this.
You share the PPT, sir. I will forward in that group.
Yeah, sure, sure. So thank you once again, the organizers and the management of the MAGR for giving me this opportunity. So for participants, if you have any doubts, I will share my details to Dr. Ravi Kumar or Dr. Subramanian sir. So through email, you can contact me for any doubts or for any this one. You can contact. Okay, thank you very much, sir, for giving me this opportunity.
Okay, thank you, sir. On behalf of organizing committee and all participants, I take this opportunity to extend our sincere thanks to our esteemed speaker, Dr. Babu Rao, sir, for delivering such an engaging and enlightening lecture on the topic of AI and ML technologies for green energy system. The innovative application you shared from the optimization energy efficiency to integrate the renewable energy sources have provided us with fresh perspective on how technology can pave the way of greener future. Your thought-provoking idea have not only expanded our technical understanding, but also motivated us to explore practical ways to implement these machine learning technologies in real-world scenario. We are deeply grateful for the time, effort, and passion you invested in preparing the delivering and impactful session. So your insights have left a lasting impression on all of us, and we are excited to carry forward the knowledge gained to foster innovation in our own work. Once again, thank you for sharing your expertise with us and inspiring us to think critically and creatively about the future of green energy system. We look forward to opportunity to collaborate with you in the future. Thank you, sir. Thank you so much. Uh, Dear audience, due to time constraint, so you can I will share that mail ID, Babu Rao sir mail ID. If you have any further, you just interact with the Babu Rao sir. So the session will be about to begin, the last session. I hope you we stay we stay in the Zoom link.
Baburao sir, thank you, sir. Thank you for sharing your valuable insights. On behalf of everyone here, I would like to express our heartfelt thanks for your insightful talk on artificial intelligence and machine learning techniques. Your expertise and ideas have truly broadened our perspective these areas. So we truly appreciate your effort in making this session engaging and informative. Thank you once again, sir, for your valuable time and contribution to this FDP. Thank you once
Thank
again.
you very much, sir. Thank you very much once again, sir, for giving me this opportunity to you and management of the NHK.
Thank you, sir. Dr. Ravikumar, kindly proceed further. Dr. Ravi. Please 1 minute, sir. Welcome to Dr. Vasu Garu from BHL. Sir, is it audible? And Vasu Garu? Your voice is not audible, sir. Please. Bhaskar, is it audible now?
Hello?
Sir. Now it is audible, sir, but voice
Yeah.
is low.
Yeah. Are you able to hear me now?
Yes, sir. Now it is
Yes, sir.
audible.
Is it audible?
Yes, sir.
Good.
1 minute, sir. Just.
Hello? Hello, Subbu garu, okay?
About to start, sir. Just one.
Okay.
Dr. Ravi Kumar.
Sir, yes, sir.
Yeah, please proceed to the next section.
Okay.
Sir is here already.
Yeah, good evening, everyone. It gives me immense pleasure to welcome you all to this faculty development program. Today, we are privileged to have with us an eminent expert in the field of renewable energy systems and fuel cell technology, Dr. Vasu Volanji garu. So, Dr. Vasu sir is currently serving as the Deputy General Manager at PHL Corporate R&D Division, Hyderabad, where he leads groundbreaking research and development initiatives in the fuel cell and renewable energy systems. He holds a PhD in chemical engineering from prestigious Indian Institute of Technology, Madras, and has over 15 years of invaluable experience in this domain. Dr. Vasu's contributions to fuel cell technologies are noteworthy. His research spans the development of innovative fuel cell systems, including PM's fuel cell stacks for stationary and mobility applications. Among his accomplishments are the development of 50 kilowatt PM fuel cell system for microgrid application, the demonstration of fuel cell hybrid electric golf cart, and patented advancement in fuel cell design. Beyond research, Dr. Vasukar has contributed to academic and industry collaboration, having delivered invited talks at national and international forums. He has also played a pivotal role in the project supported by institutions like the Department of Science and Technology, collaborating with top institutes such as IISc Bangalore and IIT. Dr. Vasu's extensive expertise and dedication to advancing clean energy solutions make him the ideal resource person to enlighten us on fuel cell technology, a field that holds immense promise for sustainable energy development. Please join me in the extending a warm welcome to Dr. Vasu sir. We look forward to an inspiring session that will broaden our understanding of fuel cell technology and their potential impact on our energy landscape. Thank you so much, sir. You please continue the presentation.
Yeah. Thank you, Dr. Ravi Kumar garu. This gives me immense pleasure for inviting me. I thankful MVGR for providing me this opportunity to give a complete whatever our journey of experience in the area of fuel cells. So I'm basically a chemical engineering and have been working in fuel cells for the last 15 years. So initially I worked in TVS Motors R&D for 1 year plus for automobile applications, and later shifted to BHL Corporate R&D, where they have been working for quite long time in the area of fuel cells of different classifications, phosphoric acid fuel cells, alkaline fuel cells and PM fuel cells. So from 2010, I've been working in the area of PM fuel cells, pursuing different levels. So basically, we are a commercial R&D people, not like a fundamental research oriented. We look for completely an application oriented research, where if you can make some kind of a promising business also. So now we felt after a long time of journey, the government, you people all know, aware of, in August 15th, 2020. So our respected Prime Minister Narendra Modi has announced that there is a separate policy and the fuel of the future is a hydrogen. So where it can be used in multiple applications. So just we can go through it as a whole presentation. You can understand now the national importance is a huge. Of course, you could see being in you people are all in the majority of them are in research oriented, and there was a fund sanction about at the parliament about 19,734 crores in the area of green hydrogen and its allied fields like fuel cells and green ammonia, and use of hydrogen more is in the petrochemical industries and desulfurization. So wherever you are using hydrogen in that regard, they are promoting the green hydrogen, where the source can be a wind or solar, could be any kind of green media, so using which you should be able to produce. And the government has a target of 5 million metric ton of hydrogen export production, and to make India as a green hydrogen export hub for the future after by 2030 onwards. So let us just go into the presentation. This is my outline. Are you able to see the change in slide? Why is it not coming? So this is what the outline of my topic as follows. Since I think from the last exhaustive sessions, you must have gone through multiple sessions, but I am sure fuel cell was not included, I guess. Maybe this was the last session where I am covering the application of hydrogen side, where you utilize the hydrogen. This is the outline of my talk: fuel cell components and how the stacks are built and systems. So importance of fuel cell technology, why we should opt for fuel cell, and current challenges and issues and solutions, what it could be. And being in commercial research, we look for business opportunities with some case study I have given, and techno-commercial feasibility. So you being in research, you look at the technical feasibility, we look at the techno-commercial feasibility. And the current status, finally, what we were doing in the BHL also. So basically, I just have given a basic glance. A fuel cell is similar to the battery device, where you have two electrodes, anode and cathode, where at anode you could see the hydrogen is disintegrating into H plus and electrons. The electrons will go out to give power, and H plus ions will pass through a ion exchange membrane, where is a diaphragm film, so which allows only the ions and not the electrons. So like what you see in the capacitors and all, but it is specific to ionic transfer. So typically the main why people are running behind fuel cell is it's for quite long time is the main advantage is efficiency. So the lowest efficiency which you could get is 45 plus electrical efficiency, but people are promising close to 50 or 47, the recent trends, and you will get a heat that is like a byproduct. If you want to use, you can use it, And the only thing which you could call as a byproduct rather than waste is a water, which is produced at the cathode. You could see as a blue color. So these are the following reactions takes place at anode and cathode, where ions released at anode and they consumed at the cathode. So at the end, you will have overall reaction. Hydrogen plus oxygen from the air will give a water with some heat. So these are the basic components fuel cell contains. This is the gas diffusion. If you see from the top to bottom, the main prime is the proton exchange membrane, which is of brown color, and that is having a supporting catalyst where you could see the reactions can take place. And GDL is provided on top of the catalyst, where the catalyst is coated. There are multiple methods for it for better distribution of the reactant gases. So it is provided with a gasket so that you can make a leak proof for the gases and coolant. And there is a separator plate which is of insulating in nature, and they are provided with a current collection plate. On top of that, some pressure plates would be there, which you could see in the next slide. So this is the typical any kind of a fuel cell which you can see will have all these components as a common, whether it is a proton exchange membrane fuel cell or alkaline fuel cell or phosphoric acid fuel cell, whatever it is. So cells are fine. Maybe at the basic level at the lab and all, you could do all kind of experiments in the at cell level. You can characterize all the material things and small areas like a 5 square centimeter, 25 square centimeter. Once the science is proven, you have to upgrade it to a TRL level 3 or 4, whatever it is. Then slowly that cells become a stack. So any single cell of fuel cell will give a voltage of 1 volts DC to 0.6. This is the typical operating band. So such number of cells are connected in series where you can get a voltage multiplication. So any application requires a higher voltage, for which you have to connect all the cells, whatever the required amount you want. Let us say if it is a motor requirement is 48 volts DC, so or 24 volts DC or 76 or 92, or let us say EV cars will have a 400 volts DC, buses will have a 650 volts DC. So all these kinds of things are required, voltage is required. So that is how you assemble the multiple number of cells in series to obtain higher voltage. And the amount of current which you withdraw, which you can draw from the fuel cell is depends on the area. So where you can manage the higher amount of current. It's like our lead acid batteries conventionally what is being used in the vehicles and other applications also. So finally, any fuel cell stack has to be supported with multiple organs or balance of plants. Otherwise, as such stack cannot power. So you need to supply a hydrogen, for which you have to provide the hydrogen through a through anode line where it is getting humidified. Humidification is required, otherwise this ionic transfer in the cell membrane, whatever you have seen in the previous slides, cannot happen effectively. To have a better conductivity of the ionic nature, you need to maintain always maximum humidification possible under saturated conditions. So for which you need to humidify the reactant gases before they are fed into the stack. So once it is entered into the stack, there will be an oxygen is being supplied to the fuel cell stack in the form of air. So how air is supplied is there will be a compressor for supplying the air, like our automobiles. You have a filter, and there is a turbo compressor where you can give the sufficient amount of air, and that has to be either cooled or heated if required, depends on the conditions. And again, that has to be humidified further. So otherwise you will not have a better ionic conductivity. To maintain the hydration levels in the membranes, you need to humidify the reactant gases. So again, whatever the variable voltage which I told you earlier, the voltage of the stack varies from the 0.6 volts to 1 volts DC. That has to be converted to a constant DC required power through a DC-DC converter. So which will go to a load which is shown in the resistance form R. And to balance any kind of a transient response, you need to have a battery to start the fuel cell as well to maintain the transient responses to balance that, which you could see in the later slides. So why fuel cells are important over conventional systems like DG gensets and other EV applications, of course, very familiar nowadays. Main thing is system compaction in terms of weight and volume. Like DG genset, you need not to have that much space. It can be further minimized. And offers the advantage of main is clean and reliable alternative energy source. And it is silent and smooth alternative to conventional energy production. And nowadays it is cost competitive in heavy transport applications, of course, in DG set replacement also. And when compared to electrical vehicles, when you go for a mobility applications, so you need to charge for at least some 40-50 minutes, though people call it as a fast charging. Whereas in fuel cells, the refueling time is just 6 minutes or 6 to 8 minutes maximum. So this is the major advantage. And whatever is happening nowadays in the green hydrogen production, so the cost of hydrogen is coming down drastically every year by year. And when comparison with the conventional vehicles like a diesel vehicles and all, so typical operating life is 7 lakh kilometers. And the fuel cells now they are promising for 4 lakh kilometers or 10,000 hours currently, but people are offering some 2-3 parties are offering internationally up to 20,000 hours also. So which meets the requirement of commercial needs of 7 lakhs plus. So 20,000 hours is nothing but 8 lakh kilometers. And if why they are better than the battery means, once you want to replace the fuel cell stack, in the period of time, you may have to replace the battery 3 times at least. So initially the battery vehicle cost may be less, but over the lifespan of the 8 lakh kilometers or 7 lakh kilometers, so they will not be cost effective in some cases. But of course, advancements happening in battery technologies also, they become cost effective and lesser every year. If you see some 5 to 10%, they're dropping the prices. But to promote the fuel cell, there should be a availability of hydrogen. So what is the national perspective of hydrogen in fuel cells is the government motto is to become a global green hydrogen production hub for exporting of green hydrogen for its derivatives or green ammonia, whatever it is. The capability of building 5 MMT, 5 million metric tons by 2030. This is the government of India motto. And the replacement of hydrogen produced conventionally from a SMR process or any means, any fossil fuel routes, they should be replaced with the green hydrogen for various applications. The first priority target of the applications to be replaced is steel production, petroleum refining, the hydrogen where they are using for desulfurization, and blending some fraction of hydrogen in the city gas network, like a PNG pipeline as natural gas will be replaced with a hydrogen also. And a phased replacement of conventional fuels used in mobility, shipping, and aviation sectors because of the pollution. And the Indian government of India has committed for the zero emission by 2070. Slowly, we have to phase out. By 2042, we are targeting for 50% emissions reduction. That is one of the motto. And to become a global leader in technology and manufacturing in green hydrogen areas such as electrolysis, biomass, and coal gasification. That is one of the main motto. establishment of hydrogen refueling stations to promote the applications or utility side. So India already has some 4 refueling stations. So that has to be enabled for the user cases, like a demonstration of fuel cell buses or trucks, whatever it is. So how do we use promotion of use of hydrogen for the automobile, either in the IC engines of hydrogen or fuel cells for transportation applications? The current cost of green hydrogen is about 600 to 800. It is varying based on the solar price. But the target price was to have a levelized cost of hydrogen with the SMR process is 200. So these are the various routes currently used for production of a hydrogen. So typically the natural gas and their energies among the fuel I have given. Obviously, the hydrogen will have the highest energy density in comparison with the gravimetric ratios. And these are the bottom is the efficiencies in every process. So the highest efficiency you could see still is a SMR process only. So that's why it is cheaper also. Of course, the natural gas is available also in comparison with other resources of fuel. And this is the current status of the Indian scenario for hydrogen cost based on the production routes. The HRS, hydrogen refueling states, which I told earlier, about some 4, they were located at Delhi, 2 numbers, Faridabad and Nice Gurgaon Center. And one is recently opened by NTPC, Leh Ladakh. And another one is, I think, about to close in Vadodara by IOCL. So the current cost targets set by the MNRE was, this is the base price is 200 by SMR process. And biomass gasification about 300 and electrolyzer at least 450 to penetrate with still acceptable. And photoelectrochemical is 800. This is the current cost, and coal gasification is on par with the SMR. So this is the recent China is so much of hydrogen being produced in China is by coal gasification because they have a huge amount of coal reserves like India rather than the crude oil. So this is the kind of technological challenges in the conventional technologies where you use in the fuel as well as in the application side. So the oil prices are, you could see any kind of international wars, anything happens, there is a volatility in the oil price, and we are so dependent on the 80% to 70 to 80% of our imports. Oil requirements are from the import zone. So that is a big geopolitical issues. And as long as you import the oil, you cannot control the emission levels. Probably instead of having a 50 years, you can extend it for another 10 years. So you cannot completely invade the emissions. So finally, you have to slowly move out of the fossil fuels. So when the time comes, you have to leave it. So the conventional IC engine efficiency is less than 30% is the net efficiency even today. And the price of lithium is keep on increasing, the raw material prices. Though we find the technological advancements, you could not feel that if you see the trading side out of the materials, the prices of lithium is every year 10% is increasing. And China is the major controller of the raw materials. And if you compare with the electric vehicles, the biggest challenge is the range. So the range is the biggest problem for EVs for commercial applications, because instead of carrying the payload, you are carrying the battery weight typically. So in case of any defense applications, you cannot use DG sets because the problem of thermal signatures and kind of emission stringent norms because of security and surveillances. So these are the challenges for the being faced from the conventional DG sets and IC engines and EV problems. Broadly, I have clubbed everything in a single slide. And this is the kind of a gravimetric density, since people are used to electrical slowly, now people are accepting it. So this is the kind of energy density on the gravimetric basis. So NCA here has the highest, where Tesla uses that kind of thing. But in India, we use mostly LFP batteries, where you have roughly the recent advancements are around some 140 plus or 150 watt hours per kg they are getting. So when I compare with the hydrogen of a type 3 cylinders, what would be the energy density giving a equivalent power? So the hydrogen stands almost 3 times more energy dense than the conventional battery systems. So that's why people are mad about the fuel cell promotion, though they were not able to still offer the levelized cost parity with the conventional engines. But now people slowly accepting in some applications. So what happened in promotion of the new energy vehicles? It is one of the case study by the China. They slowly, how the fuel is denting internationally, how the fuel is being reduced with the replacement of the uh, different vehicles, conversion of the diesel buses to e-buses, and conversion of diesel LCVs or commercial vehicles to EVs, and other gasoline vehicles to EVs. So that is the amount of oil being reduced when you are converting this many number of vehicles. So which is a huge amount. So what are the techno commercial solutions which you can offer for the challenges we were talking? Is from my personal point of view, the fuel cells could be a good game changer for the future, because it is able to meet all the requirements of pollution norms, because no emission, water is the only emission. And the main advantage is green fuel is energy independence fuel, because we can make the fuel, so we need not to dependent on any other country and import, and geopolitical issues certain level we can be happy rather than depending on it. And carbon neutral energy generation, because we have signed for the zero emission agreement by 2070 carbon neutrality. And high gravimetric energy density, which offers the compactness to use in vehicles also. And for a customer, he will look at only the price, that is total cost of ownership is low when compared to other technologies. And the biggest advantage is it is easy to integrate with existing EV train platforms. So these are the kind of opportunities in the non-transportation sector. You talk anything, wherever the IC engines can be used, you can replace every place with the fuel cell. There is no doubt. From the submarines to the drones and tankers, and of course, aviation also, people started using it now. And these are the transportation applications, people already using it in the fuel cells for typically commercial trucks and public transport buses, like a 12-meter, 10-meter buses. Already in India, about some 20 buses are flying. In IOCL, there was a project running with the government, 15 buses, and Leh Ladakh, they are running 5 buses. So, and many people are coming into India now for replacement of the EVs with the fuel cell. So let us, if you talk about the business, these are all the minimum numbers. Only one segment I have selected, light commercial vehicles. So these are the huge amount of sales in a year. So which you could see. So almost 6 lakh whales, 6 lakh on an average, you could see 5 lakhs plus sales of light commercial vehicles itself. In a year, you were able to see. And almost some, these are all the e-LCV players. Electric LCVs already started in India, about some 6 players already there. In Hyderabad itself, we have two players. In Delhi and Gurgaon, they have some two, three. Ashok Leyland, Tata IS. So these people already started coming in. In just a matter of 1.5 to 2 years, I could see almost some 6 to 8 players in LCV of electric vehicle. So this is one of the promising in to comment and the comparison with the multiple kind of technologies. So where the economy of the fuel is typical placement of the fuel cell systems, how they are all being distributed at different places. So fuel cell power plant at the end we are keeping so that it is highly safe, and DC-DC inverter or converter depends on the motor requirement, and you will have a DC-DC converter which I have shown at the earlier stage, and complete fuel cell cooling system is brought to top because ultimately it has to be rejected to ambient conditions only, and all the hydrogen storage was kept at the top of the bus. So from safety point of view, there will not be any issue. So typically, this is the kind of placement of various subsystems in the year 2012, 13, I think, where we have we have developed our own test facility where we had the uh, imported test benches also we have, but the commercial kind of running we cannot do it because where you have to use real-time air and all this kind of humidifiers, everything has to be placed inside as a system. It's like a hardware in loop simulation. Whatever you see in the real-time system, they were all placed on the test bed. All this balance of systems like humidifiers, power converters, air supply unit, hydrogen supply unit, everything was kept in a on the bench, and we used to have a complete in-house developed hardware and software by BHL. The same thing we were using. So this was completely in-house developed system, which was giving about 1 kilowatt. So this was the test results for dynamic performance. We have conducted test up to 600 hours. There was a continuous testing up to 200 hours. Then we have gone for a different driving cycles. So accordingly, we have tested. So you could see this was having a 25 cell stack. So initially you will have an open circuit voltage when the current is at 0, and you will have highest voltage. And when the current, this was designed for a 55 amps current. So we used to, the rated capacity was 55, but we used to test a little higher also. So this was the dynamic response of fuel cell for auto mobility applications, where we have developed a small electric golf cart. So you could see in the next slides, where you have a lot of, we have tested it for almost 4 years, roughly 18 to 22, I think, yeah. So 4 years, close to 4 years, we have completed testing. This is just one such snapshot. So initially the current is taken from the motor, like a vehicle when you are driving. So if you are accelerating it, it demands more current or more power. So that has to be substituted by either fuel cell or battery. So you could see that the green one, it is primarily the golf cart is powered with a fuel cell. So where you could see a green color, and this is the demand current with the red, that is motor current, which is always demanding, and the green is supplied by the fuel cell, and the battery is a purple color. So any kind of replacement or the transient response, if the fuel cell cannot give during that short duration, this is a response for only 5 seconds. In this transient of 5 seconds itself, we could see lot of, this is the real-time test data which we have taken through oscilloscope. So you could see lot of variations, a lot of up and downs. So this is how the real-time motor vehicle data is, because you will be accelerating, you will be decelerating, In case of decelerating, the speed will go down. That time, this fuel cell will charge the onboard battery also, because the battery has to be maintained always at a certain state of charge. So which is mandate. Otherwise, you cannot dependent on the any external charging. So we used to uh, maybe once in a year or twice in a year, we used to give the external charging for the battery, unless the vehicle is kept for a month in ideal condition. If we don't use the vehicle for a month, so the self discharge, because of self discharge of the battery will lose the complete voltage. So to start that motor and the complete fuel cell, we need to have a battery. Unless the battery is dead, we need not to dependent on the any external charging. So I remember typically we used to charge maybe once or twice in a year. Otherwise, we will not need to. So this is one such BHL has developed the products which can be offered for commercial applications now. It is ready to offer. So this was developed in the year 2013, I think, 12-13 year. And it gives 1 kilowatt AC power and 1 kilowatt DC power, whichever you want, you can opt. There is a port for DC, 24 volts DC it used to give. Otherwise, you can take 230 volts AC also. So we given the provision for both. So it is like a diesel genset. Just you have to press the start button, which is of green in color. So this is in case of any emergency, you can, this is a manual stop or emergency stop. Otherwise, it is having all protections. So you need not to, it's a plug and play. It's an autonomous system. You need not to worry. Once you supply the fuel, if you start the button, it will be keep producing the power. Unless there are any abnormalities, it will not shut down. So if it is a completely unmanned conditions, we have tested this for more than almost a year. We have tested it. It was running fine. And this was the vehicle I was talking about. You have seen the dynamic performance response there. So this is the having a 1.2 kilowatt BLDC motor. This vehicle is powered with a 48 volts DC 1.2 kilowatt motor, and the payload capacity they have mentioned is 280 kgs, but we have tested even for 320 kgs to 340 kgs also. And these are the fuel consumption is 18 liters per minute, and it has an onboard battery 3 kilowatt hour. The vehicle came with an onboard battery of 3 kilowatt hour, and the battery weight which they have offered is a 125 kgs, and the fuel cell system total weight is about 64 kgs. And we have removed that VRLA battery. Within the same space of battery, we have used lithium ion battery and fuel cell system together. So within the space given, we were able to manage both. So hydrogen storage weight is about 36 kgs. So all together also it is not crossing the battery weight. The storage and fuel cell system weight together it's also not crossing. And the electric golf cart mileage was about 40 kilometers when they have given us as such. We have tested it 40 to 45 maximum. So when we have made an integration with the fuel cell system, the range has been extended to almost 2 plus, means increased by another 100%. So this is one more model which we have developed it for telecommunication applications where you need a backup power of 48 volts DC. And this was developed in the year 17-18 financial year. And it was tested for almost 6 months. And currently we are developing another 5 kilowatt system for a diesel genset applications of similar same model, but in a more compact form. So this was the current status. We have developed a 25 kilowatts complete system. This is tested on the test bench. So in almost more than 150 hours, we have tested it to obtain different kind of performance data for development of complete closed loop testing. So this was recently completed in the 23rd December, 24th January, we have completed this. In fact, the multiples of 25, we have applied for some of the funding support from government. We hope that was cleared multiple stages. So we are waiting for the final confirmation from the agency. So this is the current status at BHL, and currently we were working on the 60 kilowatt fuel cell stack, and we are developing its components also. That is, so far whatever we have developed is based on the graphite plates. So where we use the composite graphite plates, having a life of almost close to 15,000 hours. But now we are moving on to metallic plates because of the BHL's core business is in railways. So we need a metallic plates to withstand the shock and vibration applications. So we have to move. So in that regard, we have taken the metallic plates based fuel cell. So it is planned to complete by 27-28 financial year. So of course, we are working on the continuous improvement of the fuel cells with the graphite bipolar plates also, because we are typically BHL business is about the power plants development. So this is like a where we work on megawatt scale. Here we work on a kilowatt scale. So we are already working with multiple clients. So it cannot be disclosed at this moment. So we are moving towards commercialization. So the myth of research of highly cost is coming into the reality now to offer a feasible solution for replacement of the conventional systems. So thank you for all your patience, and please let me know if you have any questions.
Thank you, sir. Dear participants, if you have any queries, please raise your hand, or you can post your query in the chat box. Dear participants, please, anyone, please raise your hands, or you can put it in the chat box. I already enabled the chat also.
I request participants to ask queries. Dr. Vasu sir is in online, so he will interact with you. So there is a query, sir, in the chat box.
Yeah.
How is waste heat utilization cogeneration application of fuel cells, and what are the efficiency benefits?
Yeah, it's a good one. Currently, the electrical efficiency of fuel cell systems are about some 46% to 45%. So if the government of India is targeting to replace the Leh Ladakh region, because the Leh Ladakh transporting the diesel to Leh Ladakh is almost 250 rupees. On addition, you will have a price of diesel at the ground level also. So it is when the time it reaches to Leh Ladakh, the liter price of diesel is going to 350 rupees. And the biggest challenge in Leh Ladakh is you have the low concentration of oxygen also, and they are energy inefficient, and the temperatures there are very low also. It will go to -10, -15 also sometimes in peak winter. And there was some, they started coming. We have participated in one of the tender for medical, I think one hospital, where they were asking the 25 kilowatt system with combined heat power applications, where the heat is being used for the room heating or to maintain the temperature environment of their value of 25 degrees centigrade. There it the whatever the exhaust heat we are getting, so you can maintain the room heat. With that, the cogeneration efficiency will go up to above 77 to 80%. That is the best way you can extract the maximum efficiency. So close to 80% you can get the overall efficiency if you could utilize the uh, byproduct heat. I would not say it is a waste, it is a byproduct heat. So the lifespan of the fuel cell is commercially people are offering up to 20,000 hours or 10 years. So there will not be any issue because that's what I was talking in the previous slides also. It's more of commercial. Now it could, in automobile applications, it could offer for more than 4 lakh kilometers, and where the batteries are offering only 1.5 lakh kilometers. So this is almost 3 times it is offering. So that way the replacement cost, people are only talking about the, if I go with the battery car, my price per kilometer was 1 rupee per kilometer, but which is not the case in reality. Because at the end of the 5 years of warranty, you have to replace the battery cost. If you talk about Tata Nexon, the cost of battery itself is a 4.5 to 5 lakhs rupees. And that has to be replaced whichever is earlier, either 1.5 lakh kilometer or 7 years maximum they are giving. That's it. If you use or don't use, the battery life is going to be last for 7 years. So safety wise, fuel cells, we have the on ground working systems. We have recently we are going to have one of the field demonstration. We have done today itself, we have done a lot of safety tests, inducing the leakages and emergency conditions and higher current, lower temperature, lot of safety conditions we have induced this, we have tested it. It is highly safe. In fact, I would say it is much safer than the CNG and diesel or any conventional fossil fuels. So that is the main advantage with the fuel cell. Because the hydrogen, if it leaks, it will not make a pool. So it will be going only top. So people are trying for the alternative platinum catalyst, non-platinum catalyst. People have been trying it, and people could see earlier it used to be 1 milligram per square centimeter. They used to use in the year 2014-15 year. Now the amount of catalyst used in the fuel cells is, so I am talking about the 1.5 milligram on both the sides. Now people are using only some 0.5 milligrams on. Almost they have reduced by 75%, roughly 70%. 1.5 milligrams to 0.5 milligrams now. So how to control onboard vehicle hydrogen fuel cell leakage? You cannot control, you can only take a precautionary measures. So in case of vehicle onboard hydrogen leakages, so you will have a sensors mounted, leak detection sensors. So we have a various range of sensors because in golf cart we have mounted 2 sensors, one at the storage side, one at the fuel cell side. So anywhere if it leaks, it will detect first. So at the 20% of the lower explosive limit, that sensitivity you can customize. If you want a very highly sensitive, people can shut down it at 40 to 30% of the lower explosive limit. So in case it depends on the zones. So there are different zones, zone 1, 2, 3, as per the limits. So petrochemical and all, they will have a zone 0, I think. So zone 0, where you have the presence of highly active chemicals, and zone 1, periodically they may present, and zone 2 is a clear zone almost. You will not have any kind of a flammable gases around. So zone 0 is like a petrochemical plant, where you will have always a presence of volatile chemicals, so which can combust. So for which the construction of fuel cell system itself is different. So where you have to use all ATAX approved sensors. So they should be ATAX approved means they will be intrinsically safe. So you have to buy all such instrumentation, which are almost, the price will become a double almost. And the question, can we integrate with energy storage? Please explain. Yeah. So I have shown you that golf cart dynamic performance curve. You have the energy storage as a battery, and we have our own fuel cell system for microgrid applications. We have a battery bank, fuel cell, as well as solar panels also. Our lab is completely grid independent lab. So we don't need a grid. We are powered with a grid independent. Primarily source of the power is a solar, and it is stored with the battery, and we have an electrolyzer also. So whenever it is required, it is produced. And in case of any falling short of power, we use fuel cell as a backup power also. Any more questions? I think.
Dear participant, any other questions, please?
Hope I have answered.
Sir, I have one query, sir. Suppose these fuel cells, if you want to integrate with some other new renewable energy, we have lots of renewable energy technologies.
Yeah.
So which technology actually most beneficial to integrate that fuel cell technology, sir?
See, it is case to case again. So if it is a solar, we are having a multiple technologies here. We have a solar as the primary power, and we have battery, and we have fuel cell. Of course, we have an electrolyzer also. So it depends on, this is all about hybrid energy management, which is very vast subject, where this power electronics persons can definitely help you in this regard. So any kind of thing is, you have to ultimately balance the energy configurations, where you have to give the higher weightage. So if you want to give primary source as a solar, so it can give only 5 to 6 hours a day on an average. So the balance, you should able to store the energy majority in the battery. So then only you can supply for the rest. So a lot of tenders are coming in this area for microgrid and solar with a battery assistance, to give a trouble-free power to the grid for 8 to 10 hours. So how does solid oxide fuel cells improve the lifespan? Solid oxide fuel cells, definitely they will be good candidate for the base power applications typically. So once you start it, you should run it for days, not like a PM fuel cell. PM's fuel cells like a diesel gensets. Anytime you can switch on and anytime you can switch off. So in a day, we usually run this PM fuel cell for more than 2 to 3 hours in our daily testing. But within 2 3 hours of span, we will shut down and start within every half an hour or 10 minutes, 15 minutes, a different cycle of intervals. So that is the flexibility you have, because it works from the room temperature itself. The biggest drawback in the solid oxide fuel cell is you need to reach at least some 500 to 600 degrees centigrade requirement is bare minimum. So reaching that temperature itself, you need a preheating all these loops. And how can we improve the reaction rates, reducing the cost of electrode surface area? Okay, so the ultimately whatever the catalyst you use, there is a parameter called ESA, electrochemical surface area. So whatever the effective, you have a different kind of measurements for this. There are different electrochemical techniques, cyclic voltameter and linear sweep test, and you have a electrochemical impedance spectrometer measurements. So there are a lot of electrochemical characterization methods. There are RRD, rotating ring disc electrodes. So there are multiple characterization facilities or the routes are available by which you have to qualify for the effective surface area available per gram of the catalyst. So whichever gives the highest surface area. So definitely there is a lot of continuous improvement is going on here. Every year people are doing hell lot of improvements across the globe in this area, because that is the one of the costliest element in catalyst. But people are have reduced the loads. Platinum is now it is partly used, not full. So people are using only 60% of the platinum. Some 30 to 40% of people are using non-platinum also.
Sir, I have a small query, sir.
Yeah.
What is the role of porosity of membrane in that fuel cell technologies?
Porosity impervious. It should be an impervious typically. So that is the requirement. Otherwise, it will short circuit. So that is the biggest challenge.
So what is the minimum thickness we have to maintain, sir, to avoid this short circuit?
Minimum thickness is depends on the kind of membrane thickness they use, because nowadays people started using from the 10 to 8 microns also. Toyota uses about 8 micron thickness. That is their lowest thickness they have gone to. But commercially, it depends on the application. So in case of commercial applications like automobile, people will go for a typical thickness used is 12 microns to 10 microns. And in case of residential and stationary applications, people are using 16 to 25 also. And you want more life, they are increasing the thickness of the membrane. But the problem is you will have the performance loss, because membrane is like a resistor. As long as you increase the thickness, the resistance will increase. And practically, you need an impervious membrane. There is always some porosity, internal porosity, which you cannot bypass. PCM can be integrated into PEM design. What is PCM? Can you please phase change materials or something else?
I think phase change materials, sir.
Oh, yeah, they can be used in capturing the waste heat. In combined heat power applications, probably you can use it for the capturing the waste heat. So that like a vapor absorption systems. So you can, from the heat, you can cool it also. There are multiple applications. So you need to run the vapor absorption cycle. Minimum of temperature is 80 degrees centigrade, I guess, 75 or 80 degrees centigrade. Yeah, fuel cells can give up to 85. Yeah, maximum you can run up to 85. Yeah, you can get outlet temperature 75 to 80. So which you can use it for a running the vapor absorption cycle, or you can use a suitable phase change materials where you can change the phase to withhold the heat amount. So that is up to your requirement.
Any other questions from participant side?
One more question in the chat box, please.
So membrane hydration requirement is always better if you can have as much as higher hydration, but at the same time you cannot give so much of hydration also, which will be leading to flooding. So if it floods, you will have a loss of voltage suddenly. Can we develop CO2 converting fuel cells? Yeah, you can. There is no doubt. As long as the electrochemical from the electrochemical series, so you can pick the any kind of a combination, one on the positive side and one on the negative side. So if you can find the right combination of the reactants, you can use any kind of fuels. If people are using methanol, ethanol, formic acid, any kind of fuel you can use, but provided it should be possible in the electrochemical series. So as long as you have the minus and plus voltage combinations of the reference to standard hydrogen electrode potential, you can definitely use. So people are using the as a electrolyzer also, where their CO2 is being used to produce hydrogen, CO2 and water. Where they're producing hydrogen also. There was one project is going at NTPC site. So where they're developing hydrogen, deriving hydrogen from the CO2, because CO2 is a biggest pollutant from the thermal power plant. So they have to do this. So nowadays CO2 electrolyzers are coming at the TRL level 3 or 4. I think they are at this stage, but commercial is still not available. But it's a very good area to work on, because we are going to solve biggest challenges for the nature to combat with the pollution. This is see what is the major contributor for global warming. So if you can minimize or make use of some CO2 to produce some chemicals, then it will be great. And people are attempting it. CO2 to chemicals, CO2 to hydrogen. People are developing a lot of in hydrogen also there are different classifications. Green hydrogen, gray hydrogen, blue hydrogen, where in case of blue hydrogen, they are storing the hydrogen under the deep wells, deep excavated wells. Yeah, that is carbon sequestration, they call it as. So they store the CO2 there. So to claim some kind of a benefits. So they classify it as a blue hydrogen. Yeah, that is called nowadays people are moving towards the blue hydrogen, because the green hydrogen is still not affordable cost, because commercial shift cannot happen suddenly. So it's in a phased manner it can happen. So that is the biggest challenge. But things are moving fine in a good direction. I think Ashok Leyland and Reliance working together for demonstration of hydrogen IC engines. And Tata is working on the fuel cell based buses. And the NTPC is also demonstrating at the Leh Ladakh with fuel cell buses. And there are a lot of things happening across India and the globe. So you could find this stuff in the internet. Uh, Depends on your interest, you can find a lot of stuff. But in India, they have been promoting like anything for the hydrogen relevant area. And of course, fuel cells, because unless it's like a chicken and a hen problem. So now the hydrogen is slowly coming out to the reality, to the public. So now the use cases of fuel cells have to come. So otherwise, you cannot consume the hydrogen. Once there are no stakeholders for the hydrogen, again it will become slow. So the biggest challenge for the Delhi is the pollution. The biggest advantage with fuel cells is it can purify the air quality because there were no pollutants emitted from the fuel cells. As well, the advantage here is it is always giving the water. So once you spray the water, obviously the air quality index will improve. That's what sometimes Delhi they do. If it rains, the quality of air will come below 200 or 300. Now, if you type in Google, the air quality index will show some 450, and it has touched 900 also some time back.
There one more question from the chat box.
Yeah.
From
How does temperature influence the fuel cell performance and how to control excessive generation? Temperature definitely will have a major impact. So as long as you control below 80 degrees centigrade, there will not be issue. But as and when temperature increases, you should maintain the humidity also proportionally. So if you can maintain the relative humidity around 80 to 75%, at even at 80 degrees centigrade also, you can happily operate the fuel cell. But at higher the operating temperature, you will lose the life. So it is recommended to operate always below 75 or around 70. So that is the thing. And biodegradable materials for sustainable manufacturing of PMs. Nowadays people are using molded graphite plates where the thermoplastics are being used, which can be recycled. So they cannot be a biodegradable, but it can be recycled, I would say, rather than biodegradable. Insights into hybrid energy systems from the research point of view. Now, due to propose stack design fuel cell. Yeah, fuel cell stack design from the research point of view, you have a lot of scope. You can work on the materials influence, you can work on the flow field pattern designs, and you can work on the interfacial contacts, and you can work on the porosity of the GDL materials. And the biggest thing which is people are not addressing is accelerated life testing. So if you can work on the materials degradation with respect to time, any kind of simulations and all, so that will be a good area to open up. So people are working on the material degradation in the through experimental tests. But with the kind of advancements happening through machine learning and artificial intelligence, if you can fit some kind of degradation models, so it helps a lot for the commercial information also. So that is the main advantage. So there is a big scope for the forecasting through simulations with the current data. With the current data, can you find out the remaining life? Such kind of things are more hot area now because now the fuel cells have become a commercial viable, near commercial viable. The biggest challenge is now life is forecasting through simulations. With the current data available, how could you simulate the remaining life of the fuel cell? Or what are the possible faults or maintenance aspects or timely maintenance recalling? So these are all the gray areas still people have not attempted in proper way. Maybe in the academic side, you are maybe not aware of it, but in research side, we see there is a lot of scope for the machine learning and forecasting of its future performance, and how to timely calling for the maintenance and all. So there is a good area. It's open still to work a lot. So much of progress to be made in that.
Sir, there is a query from my side, sir.
Yeah.
Actually, that I have seen some kinetic studies in that fuel cell technology. So, is there any scope for doing this kinetic study, particularly for high temperature fuel cell technologies?
High temperature means what is the
Solid oxide fuel cell.
Yeah, solid oxide. The advantage in solid oxide fuel cells is the hot area of research in solid oxide fuel cell is how to bring down the working temperature. Earlier, it used to work at 900 degrees centigrade. Now, slowly, people have brought down to below 800. Now, people are working at the medium temperatures. So, they are looking for a 550 to 650 domain because the materials have become the biggest challenge in solid oxide fuel cells. You need all superalloy materials. So like a copper nickel based materials. So which are very costly. So the cost of solid oxide fuel cell is almost 2.5 to 3 times than the PM fuel cells. Yes, of course, life is good and the efficiency is good. There is no doubt. But the advantage in solid oxide fuel cell is fuel flexibility. So you can use any kind of fuel there. As long as the temperature operates around 650 to 750, you can use any kind of fuel because of the autothermal cracking. So any fuel you can crack into hydrogen. So hydrogen rich fuels can be made through autothermal reforming. So they get reformed within the fuel cell itself.
Okay, sir. Thank you.
So there is a one query from Muhammad Razak in the chat box.
Because high energy density is essential there. I don't know what is the question fully, not because high energy density is essential there. It was left. What else? Sorry, I could not get your question properly. What you mean? Could you please?
Can you?
Could you please ask?
Maybe yeah.
Can we adopt PEM designs for aviation and marine transport? These designs are, it is specific to applications. So when you work for the aviation and all, you will have a high amount of vibration and shocks. So they should be qualified for the 20G level. So then only they can. So the designs are specific to applications. So if you want to work for the aviation and marine, better to go for the metal-based fuel cells, metal-based bipolar plates, rather than the composite graphite. So because composite graphite plates cannot withstand the G levels of not more than 7 or 8. It's very tough. Beyond 10, it is very tough because we had that, we have been experiencing that. Can we adopt PEM designs for aviation? Yeah, I think same question I have. Because high energy density is essential there. Yes, that's what I have, somewhere I have given the curve. So anything above 1.5 amp per square centimeter, that is good enough for any kind of mobility applications. People in residential or stationary applications use below 0.1, below 1 amp per square centimeter, where the life is more important than the compactness. Now, mobility applications, the compactness is predominantly demanded rather than the life also. So we can, yes, people have achieved even 2 amp per square centimeter also. So Ballard, there was a company in Canada and German few companies. They were able to, Switzerland, there were company, about more than two they were able to achieve. It's quite natural for them. Uh, any mechanical material failure studies. Yeah, you can find a lot of things in the literature. Typically, the characterization of materials. The catalyst typically may get agglomerate or they get disintegrated from the supporting materials. Carbon corrosion, because of which the catalyst area will be reducing, and the carbon, there is a poisoning of the catalyst because of the fuel impurities like CO, sulfur, which are expected to be there in the hydrogen fuel. So these are things definitely can spoil the materials in the fuel cell. There are, for every kind of method, there is a unique traits of identification with the kind of methods. They use SEM, EDAX, and FTIRs and EIS. So there were multiple methods of tools available to find out the root cause of the material degradation also. Can we use fuel cells? If we use 1 kilowatt fuel cell, what could be the cost? See, this is the cost about the capacity versus. So if you use currently the 1 kilowatt fuel cell, the present cost is 3 to 3.5 lakhs. But whereas if you talk about 100 kilowatt, the cost becomes 1 lakh per kilowatt. And if you talk about the volumes, that becomes 60,000. So it's a volume versus cost. This is capacity and volume. So they both will play the cost. Hope I have answered your queries, I guess, to the satisfaction level. So if you have any questions, you can mail me. Probably Subramanian sir have all my details. Any in detail questions if you have, you can mail me at any point of time. There is no issue. As long as in fuel cells, comes under my purview, I can definitely answer. If I cannot answer, no problem. I will take the help of some more experts who have maybe better experience than me. There were people who worked in fuel cells for more than 25 years also. Probably they could answer if I cannot.
Thank you, sir. Dr. Ravi, please.
So shall I
Sir,
move now?
1 minute, sir. Yes, please. Dr. Ravi Kumar. Dr. Ravi Kumar. Okay. Sir, thank you. Thank you so much. First, I would sincerely thank you for taking the time out of your really busy schedule to share your valuable insights with us today. Thank you for also sharing your valuable insights into the fuel cell technologies and its importance, advancements and applications of fuel cell technologies for both stationary and mobile uses. Even you have already shared something about the fuel cell products developed at BHEL. As you know, as we move towards a cleaner and more sustainable future, fuel cell stands out as a promising solution to reduce emissions and enhance energy efficiency across industries. I think your talk has not only expanded our understanding, but also inspired us to explore and innovate further in this critical field. Thank you, sir. Once again, on behalf of MISR College of Engineering and everyone here, I would like to thank you for your time and expertise. Your contribution is instrumental in shaping the discussion around sustainable energy solutions. Thank you once again, sir.
Thank you all for being patient listeners throughout this course. I think almost this is a 5 day program. We should all thank to AICT also for sponsoring this program. Of course, the organizers have taken an immense responsibility, and I should be very thankful. Conducting such a 5 day work program is not an easy task. I definitely uh, encourage this kind of programs, provided if I have the schedules, I'm ready to share my experience in future also with new updates. Maybe after a year or 2 years later, we may get some new updates. Now we are moving from the lab to the fields now. So maybe by later 1 year, maybe after 2 years, we'll have a field experience. So in various applications, like a critical zones, zone 1, zone 2, zone 0, some oil and gas sites and sea sites, harsh sites and very clean sites. We are addressing all kind of site issues, negative temperatures and like a Rajasthan high temperatures, 50 degrees centigrade. So we are going to experience it in another 1.5 year time. So maybe after a year or 2 years, we will have a different kind of feeling afterwards. So I hope by 27, I think fuel cells become a commercially, you could see nearby your cities. That's what my gut feeling is. Even AP government is also talking a lot on the green hydrogen. I think in recent times, Chandrababu Naidu uh, talked a lot about the green hydrogen. They had some discussion with, there is a company called Greenco, I think. They are planning. Of course, NTPC has a vast site in the near Vizag, about some 2,500 acres they had. And recently they have formed a company, NTPC Green, which was listed in the stock market also for 10,000 crores fund generation also. So there are a lot of happenings going on, and you could see at the end of the year or 2 years, you could see a lot of commercial thrust in this area. Thank you all once again. See you
Thank you, sir.
after a
Once
few
again,
years again.
we have a group.
Sir,
of,
please be hold for few seconds, sir. We are going to take a few snapshot along with you. Dear audience, can you please turn off your video? Hold for 5 seconds, sir. Yes, sir. My job is done. You can sign up the session, sir. Thank you so much, sir. In this peak time also, you are you are sharing your thoughts and you are sharing your expertise in this fuel cell technology. I hope in future we have more collaboration with you from our Ambassador College of Engineering side. Thank you so much, sir.
Thank you, sir.
Thank you. I think I can exit now, I guess.
Yes, sir. Yes, sir.
Yes, sir.
Okay. Thank you. Bye-bye.
Thank you so much.
Good night.
I would request Dr. Ravikumar, please proceed to the next section and give some instructions to the participants, because we have a assessment test as well as feedback on the ATAL portal, and then followed by the valedictory function.
Yes, sir. So good evening, everyone. I request everyone to log in the ATAL portal using your registered email ID. You just once you are joining in the session, joining in the ATAL portal, so there is a one feedback option will be available. So first do that feedback, just give that feedback. After that, 7 o'clock, we are exactly conducting that test. The test is actually we are provided so 20 questions. All are multiple choice questions only. So each question contains 1 mark. You can get that 1 mark. So 20 marks. You have to score at least 70% of this test. So these two steps are very crucial for generating the e-certificate. So first do that feedback. After once the feedback is over, then you have to wait for that link. So the link will be enabled at exactly sharp 7 o'clock, and it will be closed exactly 7:30. So you have only 30 minutes of time for finish the assessment test. So once the test is over 7:30, we have a validatory session. So that after that 8 o'clock we are conclude that FDP program. So kindly cooperate us. If you have any queries, you please share your doubts in that WhatsApp group as well. And please be in online so that we can have a communication. We can have a communication with you. You can, if you have any problem in this regard, you just speak out, and we can able to find out the issue, and we can sort it out also. Thank you.
Ravi, give some more instructions, because we already posted in WhatsApp group also regarding that. Instruction to the participants, if any required, please provide. So the
Dear
test.
participant, please log into the ATAL portal using your ATAL registered email ID and enter your login credentials and do that feedback option.
చేద్దాం పర్లేదు, అయిపోయింది. So, good evening, everyone. So we have a lot of problems on the ATAL portal we have seen. So please don't worry, need not worry about that. Try it. If it is not, if it works, if not works well, we will try to reschedule the test. And after discussion with the AST ATAL people, and also again, if otherwise, we'll on Monday we will send a Google form. You can. Based on that, we are going to conduct a test. We need not worry. You need not worry any problem related to that. So we'll sort out all the problems. Yes, sir. Madam, we are again repeating that. Need not worry about the test. If it is, if it works well, it's not a problem. So, but most of them are facing a lot of problems about that. And sorry for the inconvenience caused to you again. And we will discuss with the AST ATAL persons, and also again we will communicate to you regarding the reschedule of the test. Then I think either through again on the portal, or it could be like we are going to send a Google form to you for maybe based on that, I think we can give it. నేను ఆల్రెడీ ఇక్కడే మాట్లాడాను ఆల్రెడీ అనౌన్స్ చేస్తాను అనౌన్స్
Yeah, dear participants, don't be panic first of all. So there is some server issues arised in the ATAL portal. I think we'll contact the ATAL portal members on Monday. So we'll discuss it regarding these issues. So sometimes it will be happen. So because too many attempts are will be there. So because of that only, apart from that, I would like to say so we are the first actually we are conducting that FDP in online in this year. So we haven't know that these issues arises. Maybe that is also one of the problem. So yes, actually don't worry. So we'll contact the ATAL portal members and we'll sort out the issue. And if it is if they as per their suggestion, we'll share that our thoughts in that group. If it is possible, we'll try to conduct the test in the Google form. If they're accepting means we'll consider that that is as a your assessment test. If they are not accepting, then we'll ask for the permission to extend that online portal for some other day, some other time. So and one more thing actually, feedback actually you can give at any convenience your time. It's not at actually a particular stipulated period of time. You can give at any period of time. So like even if it is this portal is supporting at the night time 12 o'clock and 1 o'clock, and that time also you can able to give the feedback. So feedback is as not an issue. Apart from that, most of the problem is arise in the test session only. I hope the link is also will be expired in soon and within 5 minutes. So we will reconduct the test. So it's not a problem. We will sort out this issue. Thank you. So Subramanian sir,
Yeah.
yeah,
Same
you want to
thing.
say
You
anything?
please post on again WhatsApp group. The same thing. Please inform to everyone. Again, everyone, I'm okay. Somebody already, I think, uh, like they did not have any kind of problem to, I think, take. I think they have without any. They have taken the test without any issues. Also, somebody. Anyhow, we'll discuss with the ASCT people and. We'll again reschedule the test. You need not worry. Need not to worry about that because that is the portal problem actually. So we will again send a request to the ASCT, and based on that we will try to conduct a test, and we will inform you the reschedule date also. Monday anyhow we will inform again, because Monday only we are going to discuss with them, and based on that we will try to inform you once again. I think we are very sorry for the inconvenience caused to each and everyone, because that is the portal related problem. Only we'll know about that on Monday. So based on that, again, we will inform you. So need not worry. All the participants, and I think need not worry about anything about this, because we'll conduct a test. Otherwise, if it is not possible, even on the ATAL portal, again we'll try to send you a Google form for that. So there is no issues for anything. After that also you can give your feedback on the ATAL portal. So I think again, once again, we are informing that we are going to reschedule the test. Need not to worry about that. So all of you please join to the valedictory function. So we after that the feedback and everything, the test also will be a bit done maybe the later stage, because we'll inform you on Monday. So after discussing with the people. So anything you want to, I think Dr. Ravi Kumar kindly post the same thing on the WhatsApp group also.
Okay.
No, participants need not worry about the test and as well as the feedback related. Already somebody have already done the test, but not for all.
Feedback actually you can give at any convenience your time. It's not at actually a particular stipulated period of time. You can give at any period of time. So like even if it is just portal is supporting at the night time 12 o'clock and 1 o'clock, and that time also you can able to give the feedback. So feedback is as not an issue. Apart from that, most of the problem is arise in the test session only. I hope the link is also will be expired in soon and within 5 minutes. So we will reconduct the test. So it's not a problem. We will sort out this issue. Yeah, dear participants, don't be panic. I already told that. So the test we are going to conduct that test again. So we'll discuss with that ATAL portal members, and as per that their suggestion only, we are going to conduct that test again. And there is some issues will be arised in that ATAL portal, because so many items will be there, and altogether multiple times people are trying to log in, and the server is not supporting. So because of that issue only, this problem was arised. So I think the link will be expired. So we thought like within time only we have to conduct the test, and it's not a problem. And we are the first organization. We are conducting the online FDP program. So we are also don't know about that these problems, so this kind of problem. So I think we'll sort it out, and based on their decision only, we'll take that our decision, and that's the thing. And if they are allowing that attached in the Google form, that will be shared in the Google form will be shared in the groups, and the email also. If they are asking about particular, they are actually sometimes they will ask us to conduct the test in that particularly in the ATAL portal, and that time if it is like that, we will tell about that. So don't panic first of all. So we'll definitely conduct the retest. Thank you.
I would request all of you, please kindly join to the valedictory function. So these all the things will be sorted out on Monday. So we'll inform each and everything to you. Uh,
Dear participants, I request all the participants to join in the validity session as it's scheduled on 7:30 to 8 p.m. So kindly stay in that this Zoom link. Sir, hello, sir.
Sir, is it audible, Professor Sarvatma Jyoti?
Yeah, audible. Subramani, I joined. It's audible.
Dr. Ravikumar Garu from head of the department. Sir, is it audible to you? Professor Ravikumar Garu? Dr. Ravikumar? Dr. Ravikumar? Professor, please, 1 minute.
Am I audible, sir, now?
Audible, sir. Audible.
Okay. Good evening, sir.
Very good evening. I think participants, please, we are very again very sorry for the inconvenience caused to you because of the test. Again, I already informed you that regarding the test, we will conduct the test, reschedule the test. Now, this is the time for our valedictory functions. So very good evening to everyone. Respected chief guest, Dr. Tejas Sarvatma Jyoti, Department of Mechanical Engineering from NIT, Calicut, and our head of the department, Professor N. Ravikumar Garu, Honorable Director, Principal, Museum, distinguished speakers, organizing committee members, dear colleagues, and enthusiastic participants. It is my honor and privilege to deliver the closing remarks as the coordinator of this faculty development program on innovative green energy generation and storage technologies. I think over the past 6 days, we have had the opportunity to explore a wide range of topics critical to the future of sustainable energy. From in-depth discussions on renewable energy systems to the latest advancements in energy storage technologies, this FDP has been a journey of immense learning and inspiration. The programs are the enthusiastic participation of more than 200 participants from different institutions across the nation. The diversity of background and the perspective brought richness to our discussion and strengthened the collaborative spirit of this event. We were honored to have resource persons from some of the most esteemed institutions like IITs, NITs, central universities, and foreign universities, and research organizations, as well as industries and renowned research organizations. Their expertise and invaluable contributions have provided us with a deeper understanding of innovations in green energy and storage technologies, inspiring us to think innovatively and work collaboratively. A special thanks to our principal and management of their unwavering support and guidance, which made this FDP possible. My deep appreciation goes to my colleagues in the organizing team, faculty members whose meticulous planning and dedication ensure the smooth execution of every aspect of this program, and of course to our participants. Honestly, your enthusiasm, active engagement, and thoughtful questions have been the cornerstone of this program's success. Through this FDP, we have not only gained technical knowledge, but also framed a network of like-minded individuals committed to innovations and sustainable. Let us carry forward these learnings and work collaboratively to address the pressing energy challenges of today and tomorrow. As we conclude, I encourage you all to share your feedback, which will help us improve and make future programs even more impactful. In closing, I extend my heartfelt thanks to everyone for their support and participation. Wish you all the best in your professional endeavors. Thank you. And now I would request our head of the department, Dr. Ravi Kumar Garu. So kindly give your inspirational messages and some kind of thoughts, please share to all the participants. Thank you.
Good evening, Subramanian Garu. And first of all, good evening to all the participants and today's guest, Jyoti Garu. So first and foremost, I would like to express to my heartfelt gratitude to all the eminent speakers who delivered from the past 6 days in this FDP program. And the speakers have given very good lectures with their invaluable knowledge and expertise. And the lectures also will be truly enlightening us starting with basic understanding of hydrogen storage technologies to innovative methods of generation of renewable energy. And also appreciate the dedication of the participants, especially after the working of morning to evening and joining in the evening hours and late night the lectures are going on. So I really appreciate the dedication of participants from various institutions for attending these fruitful sessions and making the engagement also active throughout this program. And I also thank the coordinators of this FDP program for this seamless organization and smooth conducting of the FDP. I think last day we have some issue on assessment testing. So probably we can sort out this and we can able to get back to you once the issue is over. So no worry about that one. We can contact with you with the right directions, all the things. And once again, I express my heartfelt gratitude to all participants, speakers, and coordinators for making this FDP a grand success. And also best wishes for you for your continued collaboration and innovations and future endeavors. Thank you, one and all. Thank you for giving me this opportunity.
Thank you, sir. Thank you, Professor Ravi Kumar Garu.
Thank you, sir.
For your message to all the participants. And now I would request, it's my privilege to invite our today's chief guest, Professor T.J. Sarvottama Jyoti, Department of Mechanical Engineering from NIT Calicut, to address the gathering. Sir, please.
Is it audible?
Yes, sir. Yes, sir.
Okay. So good evening all, and glad to meet you again. So I'm here again for the valedictory function. I also gave a talk in this FDP program on 3rd December. So thanks for giving the opportunity again. So first of all, I would like to appreciate the coordinators, Dr. Subramanian and Dr. Ravi Kumar, I think of MGVR College, right, of engineering. Okay, and I think I appreciate the Department of Mechanical Engineering for taking up this good initiative to conduct this FDP program on innovative green energy generation and storage technologies. So I am sure that all the participants might have come across something new, okay, rather than what you have learnt in the past several years. I am sure that some way or the other, the participants might have learnt something new from this, the talks given by the resource persons. So you should not make these ideas to slip it down. So what you have to do is just try to start working on that and see if you can try to take one step ahead in these topics, whatever you have learned. And see, whatever from these lectures, now you may be getting a series of PPTs and series of materials
See, I suggest that you also go and disseminate this knowledge to your students. You also give some lectures and talks to different places about these topics. So this is how we learn, and this is how our research also grows. And at the same time, try to collaborate with the research experts or resource experts with whom you interacted till now. So this would have been a very good opportunity. Okay, this would be a very good opportunity to interact, to see further prospects in these topics, because as we all know, this is a very much relevant topic in the present scenario. Okay, so innovative green energy technologies and storage systems are the commanding topics in the present area. So this is going to rule the world. So I suggest to be active, all the participants to be active in this field. So try to collaborate with all the mentors, experts, etc. So with this, I will not take much more time. All the best to all the participants. Okay, thank you.
Thank you, sir. Thank you so much for your valuable insights. And first of all, I would like to thank you for giving a wonderful session on design thinking and innovation in renewable energy system. So we liked your
Thank you.
presentation very much, sir. And apart from that, okay, thank you for accepting this validatory session as a chief guest. So we are so happy for that in this regard. So thank you so much,
Thank
sir.
you. Thank you. Thank you. Thank you.
So dear participants, uh, so please, if you want to share anything with us, if you want to give oral feedback, anything you want to share, you please switch on your video and share your thoughts. This is for our reference. Kindly cooperate in this regard.
Yeah, good evening, everyone. Am I audible?
Yes, sir, it is audible, sir, and we can
Yeah,
see
this
you
is Dr. Sunil, Vice Principal of Narsaraopet Engineering College, Andhra Pradesh.
Okay, sir.
Firstly, I would like to convey my sincere thanks for selecting for such a nice faculty development program offered by ATAL FDP. And also, I appreciate the coordinators, Dr. M.S. Subramanian Garu and Dr. Ravikumar Garu, for selecting a nice topic. It is an apt topic in current scenario, because if you see NTPC also diverting towards green technology, NTPC green energy plant on the hydrogen plant they established at Port Blair in the last month. I think it started the generation of hydrogen fuel also. Actually, this is the nice opportunity for all the esteemed institutions to introduce a particular elective course or the revised particular curriculum on thermal engineering subjects. So definitely, whatever the people you have suggested or you have selected for the ATAL FDP program, are they have shown their esteemed knowledge, and they left a considerable remark on all the faculty who are participated. Definitely, particularly for my institution, I want to contact all these people to help the curriculum revision, because as we are the autonomous institute, for every 3 years we go for the revision of curriculum. Definitely in the next revision we will introduce with this enlightenment, we will definitely introduce a subject on the this hydrogen or green energy generation and storage technologies. So the key resource persons you have selected is a wide variety, and from national and international universities, and even though from ARCI, Advanced Research Center for Innovative Materials, Hyderabad. I know the difficulty and gathering all the resource persons from different areas, and who are having the definitely good knowledge on the particular reserve the area is a difficult problem, but the coordinator and co-coordinator worked out very well and nicely planned this particular faculty development program. I appreciate the coordinator and co-coordinator in putting all these efforts, and because it is a teamwork, one cannot do everything. I appreciate all the team members involved in floating this particular FDP and successfully conducting all these weekdays. And my special appreciation to Dr. Ravikumar Garu. He is proactive and always he is posting in WhatsApp group like anything and alerting all the faculty. And within seconds, he is receiving all the participants and he is responding. He is very energetic. And if such co-coordinators are there, definitely Dr. M.S. Subramaniam can plan for more number of FDPs. And I cannot take much more time. Thank you again for giving me this opportunity. Thank you.
Thank you so much,
Thank you
sir,
for
for your valuable thoughts, and I hope we'll take your feedback. Sir, Dr. Krishna, sir, you want to share anything?
Hello,
audible.
sir. Good evening, sir. Good evening to one and all.
Sir,
Myself, Dr. D. Krishna,
sir, is it
professor in the
possible
Department
to
of Chemical
enable the
Engineering.
video, sir?
Video, there is a problem, sir.
Okay, no issues, sir.
So, myself, Dr. D. Krishna, professor in the Department of Chemical Engineering, MVJR College of Engineering. So, let me congratulate two organizers, Subramanian sir and Ravikumar sir. They right from choosing the topic title innovative green energy generation and storage technology, which is interdisciplinary topic. That's why across the India, so different diversified branches have been participated in the workshop. And let me brief out a few points regarding the workshop. First, right from introduction to green energy technologies. In that, several speakers spoken about the innovation in renewable energy systems like solar energy, wind energy, hydro energy, geothermal energy, and biomass energy. And also in that introduction, they briefed about the environmental impact assessment, like that carbon dioxide emission mitigations, climate change, etc. Have been discussed. And also global trend also highlights increasing the adoption of green enthalpy, government policies, and initiating supporting sustainable energy solutions like that have been discussed by the several speakers. And coming to technology advancement in green energy generation, like solar power, wind energy, hydropower, biomass energy, and bioenergy have been discussed by the several others. And coming to energy storage technology, like battery storage, its advancement development, lithium batteries, solid state batteries, flow batteries, advancement in solar PV synthesis have been discussed by the very eminent speakers from various IITs, NITs, like that. And also some topics related to challenges and limitations regarding in the next generation smart grid technology, and also environmental impact assessment, technology maturities, like that. Several topics have been discussed by the several speakers. And the last one, but not least, some speaker have directed about the future directions in that utilization of artificial intelligence, Internet of Things, machine learning, hybrid systems in green energy technology. Some speakers have briefed about and enhanced, augmented about the knowledge of the green energy. It is a nice topic. Thank you very much for the organizers and HOD Ravikumar sir and coordinator Subramaniam sir and Ravikumar sir. Thank you very much.
Thank you, sir.
Thank you, sir. Thank you for your valuable feedback. Anyone you want to say? Anybody want to say?
Yes, Dr. Srinivas Raga.
Dr. Srinivas Rao Garu.
Hello.
Yes, please, sir. Sir, if possible, you please
Hello.
enable the video also.
Yes, sir. Okay, sir. Sir, can you enable video?
So already enabled, sir.
Already enabled, sir.
Sir, okay, sir.
Yeah.
Okay, good evening to all. Respected chief guest of today's valedictory function, Professor Sarvottam Jyoti, respected authorities of MVGR College of Engineering, dear coordinators, and my dear co-delegates of this FDP. Good evening, everyone, once again. I take an immense pleasure and privilege to give feedback on this auspicious faculty development program on innovative green energy generation and storage technologies. First of all, on behalf of the all participant delegates, I convey my gratitude and sincere thanks to AICTE and the authorities of College of MVGR College of Engineering for providing all the necessary resources and for organizing such a wonderful faculty development program on innovative green energy generation and storage technologies. I would like to thank all the honorable resource persons from day 1 to day 6 for their lucid, informative, insightful, and motivated sessions to grab the knowledge on green energy generation and storage technologies, which are quite useful for our future research. Thank you, sir. I extend my sincere appreciation and the thanks to the organizing committee, Dr. K. Ravikumar sir, Dr. M. Sivasubramaniam sir, and other team members who have been diligently worked and organized this faculty development program in a grand manner. Finally, I thank each and everyone who have contributed their services for successful completion of this faculty development program and looking forward for more faculty development programs in future. Thank you one and all for giving me this opportunity. Have a great day. Thank you, sir.
Thank you,
Thank
sir.
you, sir.
Thank you
Thank
for
you
your
so much for
valuable
your
feedback.
valuable feedback as well.
Thank you. Thank you, sir.
So kindly, Jagdish sir.
Yeah, ma'am.
Am I audible, sir?
Yeah, ma'am. Yes, ma'am.
A very good evening to one and all. Myself, Dr. Neelma Devi Chinta, working as Assistant Professor in the Department of Mechanical Engineering, JNTUGV College of Engineering, Vijayanagaram. As a participant, I am really very thankful to all the resource persons because all sessions are very well planned and very informative, sir. And as a participant delegate, I congratulate untiring efforts of entire team of this MVGR College of Engineering, Department of Mechanical Engineering for conducting this AACT Training and Learning Academy sponsored 6-day faculty development program on innovative green energy generation and storage technologies because the title is very apt for the better society tomorrow. And I'm very much thankful and look forward to participate these sort of FDPs in future ahead. Thank you one and all for giving me this great opportunity. Thank you.
Thank you, madam. Thank you, madam, for giving valuable feedback to us.
Thank you, ma'am. Thank you so much for your feedback.
Am I audible, sir?
Yes, sir. Yes, sir. Audible, sir.
Yeah, very good evening.
Yes,
Myself, Dr. Mohan Jagdish Kumar. Actually, I am calling from Malda, West Bengal.
nice.
So here it is too cold. Okay.
Okay, sir.
But once again, I would like to thank all the organizing team, particularly Dr. Sivasubramaniam Mendu and Rav Kumar. And I would like to thank my college administration as well as ACTE for giving me this opportunity to participate in this 1 week training program. Actually, we are also working on this particular field for a couple of years, since couple of years. But we learned so many things from this training program because particularly when it comes to the hydrogen generation and storage technology, it is very difficult to have some kind of experimentation and research in academic environment. So I really thank
all the experts for delivering such a nice information and how to start the research in the field of hydrogen energy, its storage and utilization. And I would like to thank some experts like NITTR, I think Chennai, M. Senthil Kumar, who also given how he developed the experimentation part in his NITTR in Chennai. I really very much impressed. Even though because we are preoccupied with certain academic activities, I couldn't able to attend some of the lectures, attentively, but still I feel it's a very good opportunity for all of us to enrich ourselves in the field of green energy technologies. As rightly pointed by some of the participants, definitely we will try to introduce these kind of technologies as a subject in our curriculum. Once again, thank you all the organizers and congratulate to all the participants. Thank you, sir.
Thank you so much, sir, for your valuable feedback. Dear Padmaja ma'am, you please continue with your thoughts. Please unmute it, ma'am. Ma'am, you are in mute. Please unmute it, ma'am.
I'm sorry.
Yeah, thank you.
Yeah, I'm Dr. Padmaja, working as an assistant professor of EEE and project engineer electrical in JNTU Gurjada University. And this ACTE sponsored ATAL FDP on innovative green energy generation and storage technologies is one of the best workshops I have attended so far. And I would like to thank all the experts and organizers for an informative interdisciplinary FDP. This is helpful for both the researchers, industrialists, as well as academicians in electrical domain as well as mechanical domain. And all the sessions are very well designed so that all key areas for current research, such as advanced topics on green energy technologies, solar systems, energy storage materials, batteries, smart grid technologies, whatnot, all advanced topics are covered in this FDP, which is very useful for the young researchers to explore latest advancements in the thrust areas of energy, sustainability, and climate change. And all the resource persons have delivered excellent information from their vast research experience in a very simple and lucid manner. And I would like to thank my special thanks to Srikanth sir, Sendil sir for delivering excellent information on the current topics. And finally, I would like to congratulate the FDP team of Department of Mechanical Engineering, MVGR College, for organizing the informative and interdisciplinary FDP in a very effective way. Thank you very much for giving me this opportunity. Thank you, sir.
Thank you so much, ma'am, for your valuable feedback.
I think anyone? Okay. Kindly post your feedback on the chat box also. So those who haven't orally given, so kindly post on the chat box. I think I would request, already it's delayed by 2 minutes. So I would request Dr. K. Ravi Kumar, so kindly give a vote of thanks to the Okay.
Thank you, sir. Good evening to one and all gathered here. It is with immense gratitude and a sense of accomplishment that we come to the conclusion of this 6-day faculty development program on innovation, green energy generation and storage technology, organized by Department of Mechanical Engineering at MVGR College of Engineering in collaboration with AICT Training and Learning Academy, ATAL. This program has been testament to the pursuit of academic excellence and promotion of sustainable energy solutions. At the outset, I extend my deepest gratitude to our Chief Patron, Sri P. Ashok Gajapati Raju Garu, Chairperson of MANSAS, and Patron Sri P.S. Sitaramraju Garu for this visionary and leadership and support in making this program possible. I also sincerely thank our principal Garu, Dr. R. Ramesh Garu, and the advisory committee for their guidance and encouragement throughout this invitation. And also thanks to Dr. YMC Sekhar Garu for accepting this FDP program for conducting an online mode. And special thanks to dedicated organizing team led by FDP coordinator Dr. S. Sivasubramanian Garu, along with his committed organizers, particularly uh, Mr. D. Santosh Kumar and Dr. Pramod, Dr. B. Srinivas, and Mr. Rajesh Garu. So these are the organizing members for this FDP program. So these are actually making as a four pillar of this FDP program. Without their suggestions, uh, without active involvement, this FDP program will not be successful enough. So your meticulous planning and execution have been instrumental in ensuring the smooth running of this program. Over the course of these 6 days, we have had the privilege of learning from the most of esteemed experts in the field of green energy. Let us take a moment to acknowledge and appreciate invaluable contribution of our resource person, Dr. E. Anil Kumar Garu, Professor IIT Tirupati, Dr. R. Balaji Garu, Senior Scientist, ARCA Chennai, Dr. Radha Manohar Rao Garu, Assistant Professor, University of Chile, Dr. M. Senthil Kumar Garu, Professor, NITTR Chennai, Dr. Murali Mohan Chipu Garu, Research Manager and a Research Professor at Pukyang National University, South Korea, Dr. Jinsa B.S. Garu, Senior System Engineer, Medicon Infotech Limited, Dr. Vasu Kolangi Garu, Deputy General Manager, BHL, Hyderabad, Dr. D. Sridhar Garu, Manager of R&D, Amar Raja Energy and Mobility Limited, Dr. K.R. Balasubramanian Garu, Professor, NIT Tirchi, Dr. T.J. Sarvottam Garu, Associate Professor, NIT Calicut, Dr. Srikanth Garu, Professor, University of Hyderabad, Dr. R. Bhanuprakash Garu, Power Electronics Engineer, Idea Force Technology Limited, Dr. Baburao Sir, Senior Lecturer, University of Muscat, Oman. Their expertise and dedication have enriched our knowledge across diverse topics, including advanced solar technologies, breakthroughs in renewable systems, hydrogen production and storage, smart grids, and the integration of AI and machine learning in green energy. I also commend the enthusiasm and active participation of our attendees, faculty members, researchers, and industry personnel from across the country. Your questions and interaction and collaboration have significantly enhanced the learning experience and fostered the vibrant exchange of ideas. As we move forward, I encourage all the participants to apply the knowledge gained during this program in your respective fields and to remain connected with the networks you have built here. Together, let us continue to work towards addressing the global challenges of energy sustainability and contribute meaningfully to greener and brighter future. Finally, once again, I extend my heartfelt thanks to all who made this FDP and grant set. Let us carry forward the spirit of innovation and collaboration that we have witnessed over these past 6 days. Thank you and wish you all very best in future endeavors. Thank you so much, sir.
Thank you, Ravi, Dr. Ravi. I think, dear all the participants, kindly switch on your video. We'll take a virtual photo. I would request each and every participant, please switch on your video. Dr. Ravi Kumar, please kindly take a screenshot of this.
Yes, yes. So dear participants, please be hold for a few seconds so I can able to take that some screenshots. So, yeah. Hold for 5 seconds. Yeah, my job is done. So thank you so much for your kind cooperation and attention towards this past 6 days and attending for all the sessions and make successful of this FDP program. Thank you so much, sir.
Thank you, sir. Thank you, Dr. Ravi Kumar. And dear all the participants, once again, thank you so much. We'll inform you regarding the test on Monday. Everyone need not worry about that. So we'll inform after the discussion with the ICT. Thank you so much once again all. Okay.
Thank you, sir.